It's the Friday, 27th of June. Why is my laptop set to Ottawa as its weather? I have no idea why. I've never been
Weird.
able to. It's been like that for a while. We're discussing galaxies. Let me check if the volume is on. If you could talk. Are you talking, Brad? Could you talk?
Hello. Do I need to do more talking? Hello, hello, hello.
You're good work. It's okay.
More light years. Why am I jumping so close? What the hell is that? What's wrong with this thing?
Oh. So I'll be able to check on that.
16 years, let's go.
How far are you?
From where? I'm on this side of the center now.
Oh.
Are you in the lead?
Yeah, I'm just loading up my galaxy map.
Your what map?
I'm just loading up the galaxy map. Oh, I see what you did there because we're talking about galaxies.
Just leave that map open for a bit. Like this. We're talking about this giant thing.
This galactic map.
I am.
Galaxies. That is a good idea.
Is that you over there? I think so.
Oh, and Sagittarius A, I did read that is the black hole in the center of our galaxy, is it not?
Yeah, Sag A star.
It is?
Like the asterisks. Yeah.
Why is there an asterisk? What does the asterisk mean?
I think that's to signify it as like a supermassive black hole. That's just their naming convention.
Sagittarius, yeah, because I was going to ask Sagittarius A asterisk. That's our black hole. And black holes are at the center, or they speculate, except for one. There's like one so far. The black holes are at the center of every galaxy.
I think so, yeah. That's the attractive force that kind of keeps the galaxy together.
But then how do you explain the one that isn't? What is the one that wasn't? I need to...
Which one's that? I think irregular galaxies don't. Because it's kind of like... I was trying to think about this earlier. It's like, how could you like simply visualize what's going on at a galactic scale? Because gravity's all over the place, but it's just because the gravity is so intense there. So it'd be like you have like a basin of water, like a bathtub or something like that, and it's got a bunch of water in it, and you drop like ink or dye in there, and you see it kind of just like spread around, like spread out in like all random directions. So that's kind of like how a nebula looks. It's just this diffuse cloud that's kind of, there's no real defined shape. But if you pull the plug in the bathtub, obviously it's just all sort of swirling around that vortex, which is kind of like how a spiral galaxy gets its shape. It's not falling down a drain, but it's all spinning around the central black hole.
Wait, is Sagittarius A a spiral galaxy?
The Milky Way is a spiral galaxy. Sagittarius A is at the center.
Oh yeah, because it's a black hole. Got it. Sorry.
And if you're on the galaxy map, you can see it kind of spiral around and around. And each of the like spiral arms has a name.
Wait. So this that I'm seeing on the screen, that's the Milky Way. That is the total thing around in the map, that orange and that pink and peachy white, that's our
Yeah.
Milky Way on this
Yeah.
galactic map. Okay,
Yeah.
so Milky Way is our galaxy. Sagittarius A asterisk is a black hole in the center of our galaxy. It's a black hole in the
Yes.
center of our galaxy. Our galaxy is called a spiral galaxy. I saw that there are different types of galaxies. Wait,
Yeah.
galaxies, like there's what is there, like
The ones I remember are barred spiral, elliptical, and irregular.
yeah, yeah,
I
spirals
don't
and
know.
ellipticals are common. Some
Yes.
form rings. Oh gosh, my writing. Something else, bars. Okay, bars. X shapes, irregular blobs, etc., etc.
Yeah.
And our
I was thinking,
galaxy is eating smaller ones. I didn't know that. What do you think of that?
what?
Our galaxy is eating smaller ones. What
Yeah,
galaxies?
there's actually quite a few orbiting our galaxy, and some of them have been torn apart by gravity.
Well, which
So
ones
it's
are?
not just like the Milky Way is a pinwheel, and we have little tiny clouds floating around us. They're being drawn out, kind of like wispy cotton candy,
Ooh, cotton candy.
because they can look up with telescopes and with infrared and radio signals and stuff like that. They can see these things that aren't visible in visible light,
Mm-hmm.
and they can. I think it's mostly down to what's the term for that? But it's kind of like groups of stars all moving in the same direction. They just like hypothesize that they must be part of the same structure if they're all moving in the same direction at the same speed, different to closer stars or stars around them and stuff like that. Apparent motion, I think it's called. So yeah, there's one or two dwarf galaxies that have been almost completely like they're not gone. The stars are still there, but they've been spread out in like giant orbits around the galaxy. Kind of like how something that falls into a black hole and it gets stretched out and spaghettified. It's like the Milky Way has done that to smaller dwarf galaxies.
Yeah. And there's a term for that. What it's called?
What?
Um, galaxies eating. I read about that. Hold on. What that's for? Something like
It's different than like what will happen when Andromeda and the Milky Way
our galaxy is eating
collide and
smaller
merge.
ones. Our galaxy is eating smaller ones. Milky Way is cannibalizing smaller ones, like
Yeah.
the Sagittarius dwarf galaxy.
Yeah, I
And
think
then
the one I'm thinking of
galactic
is the.
Darwinism. What do you think of that?
Yeah, I guess you could consider it that because it literally is survival of the biggest, because gravity will dominate that kind of relationship. A bigger galaxy will destroy a smaller one.
That's so mean. It's kind of
I
mean.
mean, it's kind of benign though.
Well, oh, one-
It's like if you have a car accident, the bigger car is probably going to do more damage than the smaller car. It's not because it's mean. It's just physics, doing physics.
Mhm.
But I think the one I was thinking of is the Canis Majoris dwarf galaxy,
Mhm.
because the SEMA dwarf keeps jumping out in my mind. Hold on. I'm going to pull over in space, stop my spaceship, and Google it.
Okay. I'm gonna
Oh,
actually.
okay.
Oh,
That's
what?
the fun thing about modern science is I can remember stuff that I looked at in the early 2000s,
Mhm.
and I haven't really paid attention to it in quite a while. And then looking it up again, it's like things have since been like
Change
discovered or
since.
undiscovered or changed.
Ooh, tell me more.
So I
Tell
looked
me
up
more.
Canis Major dwarf galaxy, and Wikipedia is like, oh, you mean the Canis Major over density?
What does that mean?
So the wiki page is the Canis Major over density, or the Canis Major dwarf galaxy, is a disputed dwarf irregular galaxy in the local group located in the same part of the sky as the constellation Canis Major. That's how it gets its name.
Well, why did it
So suppose
change?
it's not.
Oh, hmm
Why did it change its name?
yeah.
Maybe something like, oh, since it's totally being stretched out over hundreds of thousands of light years, it's not really a galaxy anymore. It's been dissipated or destroyed, but it's still a visibly dense area of stars, so they call it an overdensity. I don't know. We'll find out. At the time of its announcement, the Canis-Major Dwarf Galaxy was classified as an irregular galaxy and was thought to be the closest neighboring galaxy to the Earth's location in the Milky Way, located about 25,000 light years from the solar system, and 42,000 light years from the galactic center, where Sagittarius A star is. It has a roughly elliptical shape and is thought to contain as many stars as the Sagittarius Dwarf Elliptical Galaxy, the previous contender for closest to Earth, although later studies disputed this conclusion.
I have questions.
Yes.
If Sagittarius A asterisk is the black hole that is at the center of our galaxy, why
Yes.
do we dare eat any of these stars or whatever that are also Sagittarius affiliated? Why are we fucking with that? I don't understand. Are they part of the
What?
same thing? Are they part of the same cluster? What's going on there? Why are they all called the same thing?
Okay, so imagine there's a ball around the Earth that we can see through, and that's how we divide up the sky into, oh, this is over there, and that's over there.
Mm-hmm.
But we use the constellations because that's the most familiar and oldest division.
Mm-hmm.
Almost like looking at a map and dividing a world map into countries. Like, okay, everyone that knows geography is already kind of familiar with the countries. We're just going to keep going with that. And we define, oh, the tallest mountain is in the Himalayas, which is in Nepal or Tibet, stuff like that.
Mm-hmm.
So it's between familiarity and it's still working. So if it ain't broke, don't fix it.
Oh.
So naming conventions like that are if a star is in, like, say the brightest star in Sagittarius is Alpha Sagittarii.
Yeah.
If we find radio sources, which is what Sagittarius A star is, it'll probably have a funky name. I think the asterisk is for like the supermassive black hole at the center of galaxies. Cygnus X1 is named that because it was the first X-ray source discovered, and it came from the constellation Cygnus. Cygnus X1 is a famous black hole.
Oh.
Because it's one of the earliest discovered, if not the earliest. That's why it's X1.
Find up some black holes for you. Just throwback.
And then other things like meteor showers.
Mm-hmm.
The Perseid meteor shower originates within the constellation Perseus.
Oh, okay.
So all these naming conventions are basically like, wait, what part of the sky are you looking for? Oh, Sagittarius. Okay, it's over there.
And so the black hole, if we want to know where's the black hole that's at the center of our Milky Way, blah 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 blah, it's in the Sagittarius sector. Wait, is that it? Wait. Am I getting wrong? Where all the Sagittarius stuff is?
Yeah, all the Sagittarius is in the Sagittarius constellation part of the sky.
So the Sagittarius must feel like big shit then, since it's got the black hole that's the originator of our galaxy in it.
That just happens to be the direction of the center of the
galaxy. Are you Sagittarius?
Yes.
Oh, that explains everything. I'm just kidding.
Well, there's one part about that is the ecliptic. The ecliptic that all the zodiac constellations are at doesn't line up with the disk of the galaxy. So there's some zodiac constellations that are like pointing way out, and then they go away from the galaxy, like up or down, as opposed to through the disk like Sagittarius does. Mm-hmm. It just so happens that that's where it aligns, and then the other side.
Sagittarius out there must feel like hot shit.
I think Gemini is the other one.
Center of the universe.
Look, I'm not the center of the universe. I'm just the center of the entire galaxy.
Somebody could also say to you guys, like, wow, at the end of relationships, they could say, you're like a black hole, man. That's dark. Wait, Brad went quiet. Like, did anybody ever say that to you? I'm just saying.
It's dark like a black hole.
I'm
I don't
just
think so.
saying. But that's something.
Yeah,
Not yet.
Gemini's towards the edge of the galaxy. Sagittarius is towards the center. Because part of my world building was, I can't remember exactly, but I think it was something like there was like a theological divide between the zodiac, which Earth like came up with, like the zodiac constellations we're all familiar with, and a future society making a zodiac based on like the galaxies alignment, which Sagittarius would be a part, but there would be totally different constellations because the galaxy goes through different constellations.
Ah.
The ecliptic is just the line that the solar system is lined up with, so all the planets go through the zodiac constellations. Then the sun goes through and the moon goes through all the zodiac constellations. So when you hear stuff like, "Oh, the moon is rising in Aquarius,"
Yeah.
it's like it's in that sector of the sky.
Wait. Explain this to me again, like, because I'm still waking up and I'm a little slow. So
Okay.
tell me all this how, because I've always wondered about that when people are like, "Oh, your moon is in and your sun is in." Tell me about this again. Tell me about this, please, because I know we're not turning into like.
No, I know this is like a part. It's relatable to the galaxy, but our solar system is a disk. All the planets orbit roughly on the same plane. But if you look up from the Earth's perspective into the sky, this plane is like a line that cuts the sky in half.
Okay.
That line is called the ecliptic.
Okay.
The sun, the moon, and all the other planets basically follow that. So if you look up and see them, they'll be somewhere
if you go
on
outside,
that line.
guys,
You have to go
tips,
outside.
You have to go outside.
Or use that.
Or use that Sky Guide app. Yeah, I can use that.
App on your phone and just wave it around.
I'm saved. I'm saved. Yeah, exactly. I'm saved. Okay.
But things like Jupiter is in Capricorn, or the sun is rising in Aquarius, for example, is just where the planets or the sun or the moon happens to be at that specific time, because they're all moving, so it changes.
So that's why people say when they know the time of when you were born and the date, they can say that's where your moon right. Okay.
But it's always on the zodiac constellations, so it'll never be the sun is rising in Orion or Jupiter is in, Ursa Majoris, stuff like that.
Why?
Because they'll never be in those parts of the sky. They're always going to follow that line.
Unless something knocks it out, there's a collision that knocks everything out.
Well, yeah. But the zodiac is basically named because of that line. The planets kept, ancient philosophers and astronomers kept seeing the same planets in those constellations.
Herschel, where does he come in? Wasn't Herschel?
Hmm.
Herschel has something to do with galaxies. I don't know. That's the last thing I'm in. He's what?
Yeah, like the name's familiar. I can't remember.
Yeah, I can't remember now either. Okay, so let's start with galaxies. What they are, like, as massive collections of stars, gas, dust, and dark matter.
Yeah, that's another thing.
What's this dark matter about? Like, okay, we've talked about dark matter. Some people get really weird about it. How do we know that galaxies are made of dark matter? Is that a fact? Like,
okay, so that is because we haven't proved it yet. We don't know what it exactly is. We just know that when we look at interactions at large scale, like galaxies millions of light years away and stuff like that, it's not behaving the way science suggests it should if only the light that we see is there, like stars and dust and all this other stuff. It's not behaving like it should. So scientists is like, okay, it's behaving like it was. There's other heavier stuff there, or things that we can't see that has mass and gravitational influence. So that's what they call it, dark matter. They're like, I don't know, there's something there, we can't see it, but it's doing something, because we can see the results of its actions. We just can't see the action of what it's causing it. Dark energy is the kind of same thing, where it's like, okay, there's some energy there, but we can't really. I say see, but it's like we can't really detect it. We don't know what it.
Why have we decided to call it that? Why have we decided that that's a thing? Why even list it as a thing?
What do you mean?
Why are we even including it as a thing? As when we're describing the galaxy being composed of stuff? Why do we just say and dark matter?
Because
That's like saying in things and stuff.
scientifically, yeah,
Oh, okay. Okay.
it's like okay, there's stars and dust and gas and planets and asteroids, and then a huge part of
Things.
stuff that we can't really explain. So just call it dark matter. You sound smarter.
Yeah, that sounds.
That's the limits of our understanding of space right now. Well,
When
part
they,
of it. Anyway.
I wonder what will happen when they figure out what they want to call it. When they figure,
They don't know what it
when they know
is.
more.
They already know what they called it, but it's more like they don't. Once they discover it, they'll be able to make more accurate
What if they have
names.
to change it something different? Like
They
the
probably will, but
Matrix.
that's science, right? Before
Like
we had the
people will be
period
like,
of our table,
"Damn
it was
it!"
just everything's just like fire, earth, air, and water and ether, right? That's everything. There's nothing else. And they're like, actually, no. Med 11 is like, nah, fuck that shit.
There you go. Yes. Okay. So famous galaxies.
Is
Famous
this
galaxies.
you gonna name one, or is this? We're not doing another pop quiz, are we?
No, I am asking you. You can. I can. I want to hear it from you.
The closest big one is Andromeda. That's why it's probably the most well known, or one of them.
Mm.
It's the closest galaxy that is not a dwarf or a minor galaxy, and it's the same type as ours. It's a spiral.
It's a spiral like ours.
Yeah, but we can't. We see it on its edge. We can't see it from the top, so it doesn't look like a spiral to us.
But
But
we've
through
detected that
studying,
it's spiral.
yeah, I think it's about twice the size as the Milky Way. So there's twice as many stars, like 400 or 600 billion, or some crazy huge number like that. And it's about, I think it's 200,000 light years across.
We got an update about the Andromeda galaxy, by the way. Speaking of which,
Breaking news! It is
yeah, breaking
still
news.
millions of light years away. What was the
Breaking
update?
news. Yeah, the newly activated Vera C. Rubin Observatory's first galaxy images. You know, the one in Chile that has a
Yeah.
3,200 megapixel camera.
Mm.
It's taken some images of distant spirals in the Virgo cluster, nebula, and stars, 10 million galaxies in just 10 hours, and it identified 2,100 new asteroids. And over the next, yeah, so that's pretty cool. But that had nothing to do with Andromeda. What was the Andromeda news? Sorry about that. Where's my Andromeda news? Where's my Andromeda news? There's something about Andromeda going on. Something like we've learned that. Oh gosh, I'm so
It's not
sorry.
millions of light years away. It's right
It's
over there.
visible to the naked eye. Okay, 2.5 million light years away. Seen without a telescope. Farthest that you can see with your own eyes. What have we heard? There's something new about the Andromeda right now. Because of the James Webb, I think. Hold on. So not the other one, but good for you, Chile. Sorry about that.
That's still a lot, though, considering you just had first light like the other day.
Yeah. Oh yeah. They're already on it, and they got a decade to be able to continue to take images. So that's going to be pretty cool. What am I? Where
Can
was
they
it?
just call it a gigapixel camera, though, instead of having 3,200? What is it? 3,200 megapixels?
Yeah.
Just call it a 3 gigapixel camera. That's how the SI prefixes work.
The James Webb says, it says the galaxy may hold 2 trillion. There may be 2 trillion galaxies or more. It's noticing more than what we thought. Something like
Oh,
that.
yeah. Well, that's like what Hubble did. When Hubble did its, what is it, deep field picture that it took?
Mm-hmm.
NASA basically just went, okay, Hubble, just zoom in as much as you can. It's like, okay, I'm going to take a picture of this black emptiness, and zoomed in. It's like, there's just endless galaxies in there.
Oh, there's an update about like the collision time. I think that was it. Okay, the
Oh,
update. Andromeda.
it's tomorrow.
Andromeda. Yeah, it's tomorrow, guys.
We'll be
Something
fine.
like, gosh, my notes are terrible. The Milky Way and Andromeda galaxy are expected to collide, which we've talked about before, in about
Mhm.
4.5 billion years.
Mark your calendars, folks.
So, yeah.
Book that weekend off.
There was something, though, in my
Easy.
notes. I wonder when I'll find it. Like, that's too bad. I had it, like...
Probably at the very end of the episode. Tonight.
I'll be like,
Oh, that's what it
oh,
is.
by the way, what I said, like, 2 hours ago. Wow. Sorry about that. It was really exciting. So it was like there's an update about it. It is visible to the naked eye, though, 2.5 million light years away, seen without a
Yeah,
telescope.
that's pretty crazy.
It's the farthest you
It
can
looks like
see with your own
it looks
eyes.
like a smudge.
Well, no, my smudgy cat doesn't look anything like the Milky Way. But yeah.
There's probably a cat-shaped irregular galaxy, though.
Is there one? Is there one in? Oh my gosh, that would have made me more happy to see a cat-shaped galaxy than a cookie galaxy. I'm just saying, a cookie planet. I mean, if there's a cat galaxy or cat planet, I'm just saying. I know that's off topic. I'm just saying. I want to see cats in space. Sorry, cats in space.
I want to see cats in space.
Oh yeah. Here it is. Milky
What?
Way and Andromeda collision reassessed. Data from Gaia and Hubble say it's less than 2% chance in the next 5 billion years. And squiggly line 50% chance over the next 10 billion years. I don't remember what it means.
Approximate.
Yeah, there you go.
Or
there
roughly
you go.
Around
about. Yeah, so there you go. Yeah, wait. And the Lange Magellanic.
What? The Magellanic Cloud?
Yeah, that's gravity affects the outcome too. So there you go. That's your update about the Milky Way and Andromeda collision. It's been reassessed. Less than 2% chance in the next 5 billion years. So we're okay.
We'll be fine.
We'll be fine. So like, calm down. That's what I needed to tell you. I'm sorry about that. I was like, yeah.
It's actually not going to happen. Ticketmaster will not refund your money. Too bad.
Yeah, you guys thought it was going to happen tomorrow, but no. Can you tell me about some more of that, the large and small? Like, tell me more about stuff. Yeah, about famous. Yeah, tell me about stuff and things, please.
So I know we already mentioned the Sagittarius dwarf galaxy and the Canis Majoris overdensity.
Wait, tell me more. Wait, repeat that again. The Canis Majoris density. I probably didn't listen. It's definite. Yeah. I'm here. The density. The density. Yeah. You are my density. That's from Back to the Future. Yeah. Did you see it too?
So those.
Oh my god, did you say? Oh my god, we're nerds.
Well, yeah. We're talking about space.
Yeah, but
we're getting in space talking about space.
I know, but Back to the Future. You got so awesome. You my density. It's like, oh my god. Anyway, go on.
So yeah, dwarf galaxies are orbiting the Milky Way.
Over the world?
I don't remember what the theories are and how they were created. Are they like leftovers of a previous collision? They're like the debris when the Milky Way collided with something else billions of years ago? Maybe. That they formed like that, and it took billions of years for them to be pulled closer, like disintegrated. I don't know. It's hard to say. We don't know yet. Or we know a little bit, and I don't remember exactly what. But they're little. They're quite small in comparison. They don't have a spiral structure like ours does. They're either elliptical, which is like the oval-shaped one, or irregular, which is like kind of a cloudy, no defined shape. It's just a whole bunch of stars hanging out.
Hey, buddy, bud.
But I think the large Magellanic has like 200,000 stars, and the small has like something like 170,000.
How do we know?
I think they average how much light it emits.
Oh,
like it's a lot of guesstimating. Like, oh, okay, if you know how bright a flashlight is, and you see lights way over there, that's like, okay, based on how far away it is, that looks to be like about 15,000 flashlights. It's kind of like that math. Maybe it's fewer, brighter flashlights. Maybe it's more, less bright flashlights. But we're just guessing. So based on like basic science does a lot of guessing until it's proven. But based on the math from stars that we've observed and we can get more definitive information about, that's how we base pretty much everything else that we look up and see on. Like the hundreds of millions of other galaxies, we basically guess at their distance based on their brightness. It could be not as big but closer, or it could be way bigger but further away. So we prove it, we don't know.
So famous galaxies, Andromeda, which is Andromeda, the one we're going to collide with.
Giant and close, or the closest.
And we haven't
Triangulum.
Wait! I didn't see that. Triangulum. Where's that one?
Triangulum is so. I remember mentioning it to you, but I don't think we talked about it on the stream. So Charles Messier was an astronomer.
Oh, I was about to say Messier 87 M87. You called it something else. That was really the next thing in my list.
Yes, Charles Messier was looking for not galaxies, but he kept finding them, and it was like, these are so annoying, I'm going to catalog them so that I know I'm not looking for something that I'm looking for. I'm just going to kind of make a list of, that wasn't it again. But we still use that list because it was so good. He was good at finding stuff he wasn't looking for. Poor guy. The Andromeda Galaxy is M31. The Triangulum Galaxy is M33. I think he counted up to like 102 and either stopped or died.
He's like, I'm never going to find the thing I wanted to find, but here's all this stupid shit. Yeah. That's basically.
I think
he was home. Messier was the home of first. That was the home of the first black hole ever photographed. The Messier 87, M87.
Okay, that might be because the angle is. We're getting it from its good side. It might have been the angle makes us view it a lot easier. Like the Andromeda Galaxy, because it's edge on, we're looking through the whole disk of hundreds of thousands, if not millions and billions of stars. So it's hard to detect stuff like that. Whereas something that's you're looking at from the top, for example, you don't have to look through millions of stars to kind of investigate what you're looking for. Only a couple thousand.
What is the Whirlpool Galaxy?
I think that's M51.
A spiral beauty, it says.
Yeah. Some of them just get their name because what the astronomers thought they looked like when they found them. Like there's a Sombrero Galaxy.
A Sombrero Galaxy? Yeah. I don't believe yet.
Yeah, really? Sombrero Galaxy. I don't remember which Messier number it is, but.
Large and small Magellanic clouds. What are they?
Those are dwarf galaxies near the Milky Way.
And they'll be eaten up by bigger galaxies.
Are you playing Elite?
Yes.
Are you in your ship?
Yes.
View? Okay, look out of the windshield. Are you near something that you can hit?
No.
I mean, basically just put your brakes on if you're not in Super Cruise or anything like that.
I'm in Super Cruise, but I'm looking around. I see stars and stuff. I've seen little galaxies.
But you could.
What do you want me to look at? The little thing? Nebula?
But you can see. Hold on. You can see the band of the Milky Way, which should be like a reddish orange.
Yeah,
stripe.
I'm looking at it right now.
Okay, move your ship around or move your camera around.
I'm sending an image. Will you look at an image if I send it to you?
On PlayStation?
Yeah, it's sent to you on PlayStation.
Yeah. I'm trying to find it now. Because you can see the Magellanic Clouds and you can see Andromeda and Triangulum in Elite. Okay, they're there. I'll check your... Come on, PlayStation, let's go. Okay, that little spot is a nebula within our galaxy.
Oh, okay. I wonder which one it is.
Depending on where you are, I think in Elite they named the ones that we had named in real life.
Yeah.
But outside of like 5,000 light years, it's kind of like it's really hard for Earth-based telescopes or astronomers, even the really good ones, to see anything in the galaxy because there's just too much other stars in the way. It's too bright to really focus on other stuff, or we can't see it at all. So outside of that, that's why you get all the weird gibberish names that Elite just comes up with.
Oh, okay.
Like the system I'm in does not have a name in the reals. We might not even be able to see it. from Earth at all, even with crazy powerful telescopes.
Hey, Buddy
Which
Bud.
that's,
Sorry, just one moment. Buddy Bud, you're the only one that chatted, right? Because the back end says other people chatted, but I didn't see any chats. I just wanted to know if it was just me. It's just you so far, eh? Like, as in, there's other people viewing, but I mean, you're the only one that's spoken up, right? I think so. I think Buddy Bud's the only one that's spoken up so far today.
hey, buddy,
I, I had it on, yeah, I only see mine so far. Okay. Oh, Ark says he's the only one that I see too. Hi, Ark. Like,
hi, Art. I'm gonna send you a picture.
okay. Wow. Okay. Hey. Yeah, I just wasn't sure because the back end had said other chats. And I had subscriber only on just to try and follow the protection thing, but as long as I don't get reactions, I'll keep it this way. Good to see you both. Okay. I just want to be sure, because... Hello, Brad. Good to see you. Hello. Oh, no. Oh. Oh, no.
Hello. Okay, so I sent you a picture of what it looks like out the windshield of a ship in Elite, of the Magellanic Clouds.
Well, what if you... Oh.
And you can see them from... So there's a...
Well, why not put that in the... Why not put that in the Discord?
I have to set it to PlayStation so that I can use my phone to scrape it off of PlayStation.
I got it. I'm just gonna pretend like it's mine.
Oh yeah, you can just do that.
I'm just gonna like brighten it. Okay, and then I'm gonna put it in the Discord, and I'm gonna say via Brad. I'm gonna put it in the research lab. I know it's an image, but we're gonna put it in the research lab via Brad.
We're talking about real science. Boom.
Yeah, Brad. So, yeah, example of what? What is it again? How is it spelled again?
It's Magellanic. So Magellanic, because they're named after Magellan, because he found them.
Magellanic
around
clouds
the southern hemisphere, like what the fuck is that shit?
In space, in Elite Dangerous. Yeah, apparently.
So spoiler alert. The big one's called the Large Magellanic Cloud, and the smaller one is called the Small Magellanic Cloud. Aren't we so creative with their names?
Yes.
But they are irregular dwarf galaxies that are a couple 100,000 light years away, so pretty close as far as galaxies go. Mm-hmm. But I don't think they have. They at least don't have an active nucleus like Sagittarius A does. So. They might have a supermassive black hole somewhere, but because it's not consuming stuff and radiating energy, we can't really see it.
What happens when our black hole no longer has an active nucleus? Then it's called a dead.
No,
would that make our galaxy die?
Not necessarily. So active galactic nucleus is a term that we use for galaxies.
Sounds like a Beach Boys song.
Kind of. Or Aphex Twin or something like that.
Yeah.
But they're active because it's consuming material and then radiating it very energetically, either like gamma rays or X-rays, or not so much visible light, but gamma rays and X-rays are more powerful than visible light on the radio spectrum. So it's like, holy shit, what's going on over there?
You know how we've talked about black holes and that they can like die or whatever? They
evaporate. Yeah.
What if our black hole evaporated? What happens to our galaxy?
That, because of its size and mass, it will take an extremely long time.
I know, but what would happen to us? What would happen?
The galaxy would kind of dissipate, I think. Stuff would just slowly stop being attracted to the black hole.
Yeah, we aren't interested in the black hole anymore. Fuck you, Sagittarius.
But I guess it would be a tipping point where, okay, Sagittarius A isn't pulling stuff towards it, and it would be other material in the galaxy will
be like, it's our turn.
Well, no, but like because it's all down to gravity.
Will another black hole roll up and go, hey, I got this?
No, the galaxy would basically break apart into areas that gravitate towards each other.
Oh, well, maybe that'd be a good thing. Maybe we don't need Sagittarius A.
I feel like the universe isn't old enough for that to have happened to
How?
Like on a larger scale, like that, like maybe that's how the Large Magellanic Cloud came into existence. It was a larger galaxy that basically fragmented because of gravitational disruption, and then that's just a little clump of a galaxy that got lost. But I don't think the universe is old enough for a supermassive black hole to have
Three
like
suns. I've got
dissipated
three suns. Sorry.
by heat death.
Yeah, but three suns. I can fuel scoop three suns. This is like getting
Are you sure you
extra.
can fuel scoop them all? I mean, you don't
Well, I
really need to.
am. I don't need to. I'm just doing it anyway.
That's like finding a place that has 3 open bars. It's like that's cool, but I only really need one.
Hey, Bill, but still. Wait, maybe that's four. How many? How many suns was that? One, one, two, three, four, five. Wait, how many was that? That was. Well, please. Oh shit, she's gotta slow down. Okay, okay. No, 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 no. Stop. I think it was only three. Sorry about that. That was really exciting. Okay.
She's freaking out.
Freaking out. Let me look at my system map. See how many it was actually. Uh. Oh. Whoa. One, two. Wait.
I get
No, it was
thalassophobia in the
two.
galaxy map sometimes. Spooky
What's that called?
emptiness.
Wait, what?
Thalassophobia.
Dwarf stars. So they are. Wait. So I got a Class K star, a Class M star, a Class L dwarf star.
Pop
Class
quiz
L
from the
dwarf
stars
star.
episode. Which one is the hottest of those stars? You have 5 seconds.
It was the top one. It was a big one, right? It was definitely the Class K.
The big top one, that one.
Yeah, yes. I mean, I'm like, man, I'm just gonna say it's the hottest. I don't know. Might be biased. Happy 600, says Buddy Bud. Thank you, Buddy Bud. We don't really. You guys can feel free to talk about galaxies too. You know, I would love that. I mean, you know, I have to. We're just still warming up, I guess. So just saying, if you guys wanted to, just throwing that out there. Galaxies contain the raw material for stars and planet formation. So basically, when I was tripping over the star episode about how we're made of stars, we're made of stars, but stars are made from galaxies. So
In a
we're
way,
not just
galaxies are
stars.
made of stars too,
Okay,
because the whole spiral structure is basically groups of stars.
so then we are stardust, but galaxies are also made from stardust. But galaxies also hold. Wait. You're
The
off.
universe, the universe is
I haven't
cyclic.
heard from you. Bye. Have a good evening. Our universe is cyclic. Yeah, because basically galaxies form stars, but they are formed from stars. How?
Well, galaxies are made of dust and gas, and they coalesce to create stars over billions of years.
Mm-hmm.
But the whole structure of the galaxy is basically where those stars are. I'll send you another picture.
Okay.
That's the galaxy map. You kind of go to the edge where a lot of the galaxy itself is invisible, but you can see the Magellanic Clouds.
Views from outside the galaxy. Wait, what is that?
That's the galaxy map, but if you go to the edge and zoom all the way out, like as far as you can, those are the Magellanic Clouds.
Oh. Oh, I see. That's a much better view of them.
Yeah.
Okay.
But like anytime someone from Earth looks at them, it'll be like the first picture where we have to see through a lot of other dust and gas and other stars are kind of. It's like a good form of light pollution because it's just other astronomy, but it's in the way of stuff we want to look at.
I will also put that via Brad because I can up that.
And then if you look in the other direction, you get this.
Yes, send in another one. Okay. Hold, please. Oh, wait. I know. We're almost there, guys. doing old people typing stuff. It's phone stuff, man. I'm just waiting for the next image. Did you already send it? Yes, you did.
No.
No, you did. No, he did. Okay.
Well, I sent the Magellanic Cloud one.
Mm-hmm. Yep. I didn't know if there was another perspective
yeah.
you're sending. But yeah, so yeah, the whirlpool galaxy, blah, blah, blah. Okay, so heavier elements like carbon, oxygen, and iron, which are in us, remember we're made from that, are formed in stars and then spread as supernova. And how do we see galaxies? We see them with telescopes like the Hubble, the James Webb, the Vera Rubin Observatory, which is in Chile, which I mentioned just earlier. I gotta ask Brad about redshift and how we know galaxies are moving away. So I'll get him to ask. I'll ask him about that when he's done sending me this stuff.
Okay. Cool.
Yeah, redshift. I want to know about this redshift stuff because I don't understand.
My PlayStation's having a fucking heart attack here.
Oh, it's like, what are you trying to do? Take images and stuff? So your next image is just from your...
Errors occurred in the system software. You fucking piece of shit.
Are you... So is this view just you inside? What are you looking at? Just the Milky Way and stuff, or?
Hold on a second. I got like a blue screen on PlayStation.
I know, but
piece of shit.
The last image you sent me is inside your ship, though. Oh, okay, I got you. Okay. Andromeda is a small piece of light. Okay. Listen to the crunchy sounds.
I'm waiting for my PlayStation to stop being useless.
There you go.
Okay, so I sent you one picture from inside my ship, Magellanic Clouds. 2 little puffs of blue color. And then the picture after that, view from outside the galaxy, is the Magellanic Clouds, but on the galaxy map, not from my ship.
And even though they could have gone in the Elite Dangerous section, I put them in this episode one, in the research lab to go with all my stuff about galaxy.
Well, it's topical.
Links, because yes, it's with the topic. So
the third picture, Andromeda is a small smudge of light, just to the right of the center dot in the middle of the screen. Then I got one more picture, and then I'm done sending pictures for the time being.
I got a question for you when you're ready.
What is the question?
Buddy Bud asks, if stars rarely collide, then what all exactly is happening in a galactic merger?
Ooh.
That's a good question.
That's a good question, but I don't think it has a quick answer. So galactic merger is kind of like... It's like taking 2 buckets of sand and mixing them together. Like the individual sand particles aren't smashing into each other and destroying each other like a stellar collision would do. Because there's a huge amount of empty space in between all of the stars.
Most of them won't even touch. Yeah.
Yeah. So when the Milky Way and Andromeda merge, because that's why they call it a merger more than a collision. So it's kind of like there will be stars flying by the solar system, maybe close enough to disrupt the Earth's and other planets' orbit, or maybe we'll just see a bunch of stars fly by and be like, what the hell was that?
Yeah, like I was reading something about that. That was even in my notes, buddy, where it was like, when it happens, some of the stars won't be as dramatic as we think.
A group of people, like say you're in a group of like 20 or 30 people, and you're walking as a group together, and you walk through like another crowd, or like you and your friends are walking down a busy street. You don't physically bump into every single person you walk by,
unless you're doing it on purpose.
But just for like say explanation, you can certainly pass by each other totally fine. Maybe if you're far enough, like if the 2 groups of people are spread out enough, you don't even have to like maneuver. You just like walk in your straight line, and they walk in their straight line, and you miss each other. So the stars and the galaxies will do that, but gravity will eventually, like it will absolutely influence them, but they have to be close enough for it to be like, whoop, nope, come over here, and start whipping stars all over the place.
That sounds... So
But
much going on there.
because,
It's hard to predict. I suppose a lot of variables is an understatement, says Buddy. But yeah,
yeah,
but yeah, with
I
all the
think
space. Oh,
I think supercomputers couldn't even be able to guess yet because it's way too much stuff to like calculate and figure out.
like they can't. They certainly can't say, "Oh, well, this star will hit this star, and this will move this part, and
Yeah.
Andromeda will, you know, be, you know, will destroy all this part of the Milky Way, and Milky Way will, they don't know yet, right? Hey, that's a question I
There's,
have. Is there okay? The black hole at the center of Andromeda, is it stronger than ours? Is it bigger than ours? What's going on over there?
I think it would be because the galaxy is larger.
It's larger than ours. But does it have a like? Is it more alive than ours? Like, does it have a dying black hole or no? Like, is it younger than ours? If it's older than ours, you know how
I don't.
galaxies get older.
Well, everything gets
Maybe,
older. That's how time works.
yeah, but galaxies get older too, which I learned today. So if galaxies get older, what if by the time Andromeda gets here, it's too old to like really affect our?
Black holes need like an incredibly long time, even on the scale of the universe, to like fade away and start dying. And like I said, the current prediction is 2.5 million years for collision, or a billion. What was it
Oh,
again?
it was something
Anyway,
like
the collision will
yeah,
happen way sooner than the black holes at the center of the galaxies will fade out like an old campfire.
yeah. It's like what was it again? Less than 2% chance in the next
Yeah.
5 billion years. Yeah.
Well, I found. Oh,
Uh,
okay, cool. I
yeah,
found
we
a
got time.
collision simulation video.
Oh, you did? Oh, that'd be good in the research. That he found a simulation video of the collision of Andromeda and Milky Way. It's going to go in the research lab section, right? Or in the
Yeah,
Let's
because it's like
Discuss podcast. Which one?
because I know I've
Wait,
seen.
will it go in the Let's Discuss
Calm the
section?
fuck down.
Well, I'm so unsure. I am calm. Buddy Bud says, can we talk about galaxy shapes a bit? And do you think the shape of a galaxy affects the likelihood of forming life? That's a good question.
Ooh, yeah, that's a good one too.
Buddy Bud holding it down.
Maybe the shape does kind of influence whether life develops or not. Because solar systems have what's called the habitable zone, or the Goldilocks zone, where it's like, okay, any
What is it?
closer and the planets are way too
Too hot, too cold?
yeah,
The
like
Goldilocks
Goldilocks' porridge. Yeah,
Oh my gosh. It wasn't her porridge, by the way, guys. It was a bear's, but anyway.
she found it. It's hers now.
That's
Law,
all the bears decided.
Possession's 90% of the law. Anyway, the habitable zone in the solar system is because either if you're too close to the sun, water will boil. If you're too far away, water will freeze. So the habitable zone is where water stays liquid. It's theorized that galaxies have this same kind of like concept, where if you're too close to the galactic center, there's way too much radiation, or the stars are too close together, so there's just too much radiation from either X-ray sources, other stars. There's just too much things happening, stellar collisions, supernova. It's just too busy for life to form, or at least life as we know it. Maybe there's life that needs that kind of energy, and it does develop there, thrives there. And then conversely, farther away, the stars are too far apart, the stars are too cold, the stars are too old to develop life that we know it. And because the Milky Way and other spiral or barred spiral galaxies are kind of like a pinwheel or a pizza or a vinyl record spinning around, and has kind of this very defined disk and shape, maybe elliptical galaxies, because it's just like an oval or like a spheroid kind of shape, maybe the rotation isn't as regular, so stars will move around and not stay in like a consistent distance from the center, so life can't develop because of that. It might be moving through a radioactive zone and moving out of it too frequently in terms of maybe every hundreds of billions of years, or so hundreds of millions, sorry. So yeah, life can't develop like that, because life took billions of years to get to this point here.
So we're just wanting to know, is a spiral galaxy more likely to have life? Is that the consensus? Do people know?
No, we don't. We don't know. We haven't
Shit,
even
I
found
just
life
shuffled.
outside the solar system, so maybe, but that's a guess. That's one of my guesses. It might be because of that. Maybe little galaxies need, or maybe galaxies need that kind of defined structure to make life more likely.
We can only guess based on ours, also.
Well,
But
that's it. It's kind of like the solar system where we're like, oh, well, Earth is the only one where we've seen life, so maybe all the like a planet like Mars or a moon like Europa or Ganymede or a planet like Mercury can't develop life. It's only because we're the only life that we've seen evolve.
oh,
Like here on Earth, not just humans, but Earth's life. Whether it's bacteria or fucking sharks or whatever.
sharks.
Shark bacteria. But there might be other
Shark
kinds of
bact-
life that
Shark.
that needs an intense radiation, and that's how its energy demands are met. Just like plants need sunlight for photosynthesis. They might need gamma rays to perform what their cells do. Whereas gamma rays would fucking kill stuff here on Earth.
So what about this redshift stuff? Redshift and how we know galaxies are moving away. I'm curious about that. And we'll come back to shapes of galaxies. Don't worry, buddy bud. We'll come back.
So redshift, blue shift, I know we talked about that. I don't remember what episode it was. Might have been the stars episode.
Oh, wait.
What?
I made a note about red and blue. Hold on, let me find it, or else why did I write it down?
Blue's moving closer,
Wait,
red's
wait,
moving
no,
away.
don't write.
No, too late.
Sounds
Spoiler
smart.
alert.
No. I wrote it down. No. Okay. Colors of a galaxy tell its story. Blue galaxies, lots of young hot stars forming. Red galaxies, older stars, no new ones forming. And then it's termed like alive
That's
or
different than
retired.
shifting.
Blue
That's
and
not. That's not shifting, though.
does that have anything to do with it?
That has to do with the spectral types of stars. So that's like O and B type stars are younger
No,
because
but
they only
this
have
is
a light.
galaxies. These are called blue galaxies and red galaxies.
Okay, so step back a bit, and if galaxies are groups of stars, then the color of the stars in it will determine the galaxy's color, right?
Right.
Right? So a galaxy that's kind of inherently blue implies it will have more blue stars in it.
And then it's alive with a lot of new forming stars, and it's hot. And then
Because blue and white stars are on the hotter end of the spectrum, and they have a younger
and the
life
red
cycle.
ones are colder and old.
Yeah.
Buddy Bud said,
type
got
stars
excited
look for,
when
like,
she was talking about hot young stars in our area. Buddy Bud, well, you know.
find hot young stars in your area.
Oh, the quest line. The star quest line. Sorry, too soon. Anyway, go on. Red.
The other like direction is M and K type stars are oranger and redder, but have much longer life spans.
What about redshift? I'm like so curious. It has nothing to do with the episode, but I used to call the quest line when I was younger. I'm just saying. Okay. Redshift and how we know galaxies are moving away.
So this was. So I remember, like I said, I think it was the stars episode or the one before that, where kind of like how the Doppler effect, where you hear a car or a siren drive by you, and it kind of distorts the sound. You know what a siren sounds like, but when an ambulance drives by you, the sound changes because as it's driving towards you, the sound waves are compressed because the distance between you and it is consistently closing, and as it drives away, the same sound waves are getting stretched out because the distance between it and you keeps getting further and further away. So light, because it propagates through waves the same way as sound does, as things move closer to you, its light wave will be compressed, which means its wavelength is shorter, and shorter wavelengths of light turn blue. And as they get further away, they'll get stretched out, and light of longer wavelengths turn red.
So that's the redshift thing.
Yeah, so that's how we know redshift is moving away and blueshift is moving closer. or things that you're moving towards will turn blue.
Okay. Sorry. Dark
So
matter.
it's a distortion of light, is what
Okay.
redshift and blueshift is. But we can tell the direction of movement.
Dark matter. Galaxies don't spin right without it. How do we know?
That was like what I said earlier, where we are observing
Did you just
the
send me
motion of
another thing?
galaxies. Yeah, it's Andromeda with Triangulum from the galaxy map.
Wow.
It's really hard to see Triangulum where I am through my windshield because there's too many stars.
Okay. So
But those are the two dots to the, like, above and to the left of my cursor.
Oh, okay.
Which is the blue thing.
Got it. Enhance. Hopefully people can tell that, because that's a little not so...
Yeah, it's not super obvious, but that's the best picture I can get from 2.5 million light years away.
Gonna have to go closer next time. So I'll try. I'm not sure people...
That was something that, was it FM Grown?
There are some galaxies that are even theorized, says Buddy Bud, to be mostly dark matter or even have nearly none at all. Exactly. It's freaking weird.
Whoa.
What happened? What does that mean, though?
Yeah. So a spiral galaxy kind of looks like a pinwheel or a whirlpool.
Mm-hmm.
If we take the observations that we've seen and kind of plug in the math and be like, what's happening here? The math doesn't work out to what we're seeing.
The math isn't mathing.
So that implies there's something like, A, we don't understand our own science, which we're not humble enough to admit.
Mm-hmm.
But also that there might be something that we can detect because we can see what it's doing, but we don't know what it is or how it's doing it or what the story is behind it. So just to explain away that mystery behavior, we just call it dark matter. There must be some mass there that's influencing how the galaxy moves, but we don't know what it is and can't explain it. It's a ghost.
So the galaxies are held together by something we can't see, and that's dark matter.
It's the Force, okay? Obi-Wan told us. He finds everything again.
Up to 85% of a galaxy's what might be dark matter. I don't know. What would hold galaxies together? So dark matter holds galaxies together? That's what we're guessing.
Maybe
dark matter, but we don't know. Galaxies are held together by some... Is it called come back to gravity? Is it just gravity? Why don't we just say it's gravity? Why are we saying it's dark matter and not saying it's gravity?
Because because if we look at stars and dust and everything, we know that all has gravitational effects, but there's more than that. There's more gravity happening than we can see or explain. So scientists are like, there must be some other heavier stuff there that we can't see. Let's just call it dark matter for now.
We haven't identified it yet.
No.
I wonder when we will.
When we spend more on telescopes than military budgets, maybe it'll be a start.
Okay.
That's a start.
And each, like I said, every galaxy has a supermassive black hole. Ours is Sagittarius A X asterisk, which we talked about at the beginning, which I thought was cool. Now this is where we get to galaxy shapes. We already did spirals and ellipticals, which just remind me of, like, why do they call a bike machine elliptical? What was that about? Why did they name it after a star?
Elliptical just means oval shaped.
Oh.
So an elliptical machine has an oval kind of cycling mechanism. Elliptical galaxies have an oval shape.
And I did already talk about our galaxies eating smaller ones. Milky Way is cannibalizing smaller ones, like the Sagittarius.
Big fish eats little fish.
Yeah, we already went over that. We can see billions of galaxies light years away, 13.5 billion years ago. GNZ1? What? We can see that far away. What I want to know is how telescopes. Active galactic
Jesus.
nuclei. Yeah,
Yeah.
AGN.
Yeah.
Relativistic jet streams of particles moving at near light speed across
Yeah.
millions of light years, powered by central black holes. That's what we're seeing. But some of those stars are
Yeah.
dead? Like what?
Okay. What do you mean? What are you
Isn't
asking about?
some of it dead that we're seeing though? Some of the galaxies, that far away? Wouldn't they be dead?
Some of the stars in them might be dead. Yeah.
Okay,
In
that's
fact, the farther away we see them, the more likely the stars are to have died.
Oh, yeah, yeah, like but it
Like our
said
sun, our
oh,
sun is going to live for a couple billion years.
we'll be seen by some other galaxy but we'll be dead. Long dead. It's not
So a sun-like star in a galaxy that's 10 billion light years away has probably already like died,
okay, so
or
our
at least
gal
gone to its red dwarf stage.
so our Milky Way, it would look to other people like a hot young galaxy still, right? Like a blue galaxy. Are we a blue galaxy or are we not a
I
blue
think it's
galaxy?
in the middle somewhere. I think.
We're not a blue galaxy? Are you trying to tell us we're not hot and young anymore? What? How offensive to Milky Way. No, is the Milky Way hot and young or not? I need to
I don't think
know.
so.
What is it then? What is it termed as?
Like neither of those.
What is it? If they've a blue or red, what are we? We're not a blue galaxy? Because we don't have hot and middle
When you're a
age.
politician, there's more options than
Buddy,
blue or red.
Buddy Bud says hot and middle aged. I appreciate that comment. Thanks so much. There you go. Or Brad appreciates it. Hell if I know. Anyway, there we go. Okay. So James Webb telescope suggests the universe may hold 2 trillion galaxies or more. That's a lot more than we used to think. We used to think of billions. Now we're in like the trillions. And some galaxies don't have dark matter. Galaxy NGC 1052 DFZ. Holy shit, I don't know. Little to no dark matter. Why is it different? How did it form?
Does it say how they figured that out, or are they just guessing?
I don't know. Science. Why is it different? How did it form? Do you know anything about it?
You basically said a sentence. I don't know if that ultimately defines all the scientific knowledge about it.
That's why I was going to ask you. I was going to be like, do you know about this galaxy NGC?
But if we think that, okay, this galaxy's matter is moving in ways that the light we see from it doesn't suggest, maybe there's dark matter there, maybe that galaxy is acting almost exactly like the science that we understand suggests it should. So it's like, yeah, there can't be any dark matter there because we understand it. And if we understand it, how is there that stuff we don't understand there?
That's
I feel like it's naive and very human to just be like, oh, there can't be any dark matter there because we get it. It's like, well,
maybe it's tiny dark matter, like those tiny black holes that we don't see.
Maybe it's dark matter in areas that don't totally warp our understanding of what we see. So something is not there. It's just not influencing it like we predict. You can't even predict the weather with accuracy. What are we talking about? Oh, we know how a galaxy is created hundreds of millions of light years away.
Right?
Calm down, humans.
Right?
You know squat.
Although, not to offend any meteorologists out there, I don't want to isolate my meteorologist audience that I might have out there that is stumbling upon this stream going, hey, you don't need to diss my work.
I mean, it's basically it's glorified guesswork. I mean, you're doing your best, not dissing it.
Hey, like seriously, if you're a meteorologist, you speak up for yourself right now in the chat. Don't take this shit. Okay, a small galaxy.
It's not shit. It's more accurate than a weather prediction. You're taking science and going like, yeah, science might do that. The weather might do that. It might not, but
a small galaxy would be Segue 1. That would be an example of a small galaxy. SEGU.
Nice segue.
Tell me, yeah, nice segue. No, but for real, do you know anything about that one? Like, where is it?
How is it
Is it
spelled?
SEGUE1?
Does the
Number
article or
one.
whatever you're reading tell you where it is?
No,
Well, what the fuck? What are you reading?
I was just things I was hoping that you'd know about. It might be after your time.
Segu 1.
SEGUE1. Yeah, it's funny.
It is a
Pew, pew,
dwarf
pew.
spheroid galaxy or globular cluster situated in the Leo constellation, discovered in 2008
Leo?
by the
Wait, it's
Sloan.
in Leo? It's in the
Yep.
Leo That's my birthday's July 25th, everyone. The same. The same. I'm Leo. Finally, a Leo
It's
thing.
located,
But why is it gotta be the smallest? Damn it. Oh well. I mean, that's it. That's fine.
it's located about 75,000 years away from the sun. It moves away from the sun with a velocity of 206 kilometers per second. So
Wait,
it
say
is.
that louder. Say it louder for the people in the back. He's
Ooh,
learning.
okay. So it's like the other one.
What about it?
So
What?
it's another dwarf galaxy that's orbiting the Milky Way, and the Milky Way's gravity is
Hydrate.
distorting it.
Mm.
Segu 1 has a noticeably elongated shape with the half-light radius of about 30 parsecs. This elongation may be caused by the tidal forces acting from the Milky Way galaxy if Segu 1 is being tidally disrupted now.
Oh.
Because the light we see from it is 75,000 years old.
No one can hear you hydrate in space, says Buddy Bud. I did hydrate, but did you hear it? You heard it. Look at that. We're
The name
learning
is due to the fact that it was found by the Segu program,
Oh, what's that program?
the Sloan Extension for Galactic Understanding and Exploration, so SEGUE. Because the Sloan Digital Sky Survey found it
Oh, well, good for them. When?
in 2006.
Oh, so it's so new. No wonder you didn't know about it. It's like,
2006 was 19 years ago.
shut up. It wasn't. Shut up.
Properties.
Don't make us feel old. I didn't mean
Segu
to
1
tell
is one of the smallest and faintest satellites of the Milky Way. Its integrated luminosity is about 300 times that of the Sun, which is much smaller than the luminosity of a typical globular cluster. Observations indicates that its mass is about 60,000 solar masses.
Oh, well.
It's
a small galaxy, though. Where it is
a high mass to light ratio implies that Segu 1 might be dominated by dark matter.
Ooh.
So again, that's like there's our detections
we don't know anything more.
Our observations imply that there's more mass there than the light from the stars suggests.
Oh. So we're just gonna call it dark matter. Like, we don't.
I mean, talk to scientists about that. In addition, any mass estimate is based on an implicit assumption, which there are kind of a lot of in science, that an object is gravitationally bound, which may not be true if the object is in a process of disruption.
And what are processes of disruption like when it's in the process of being destroyed or dying?
Being destroyed by another galaxy like the Milky Way.
So the Milky Way is trying to hurt it? Is the Milky Way trying to hurt this little small galaxy that has to do with Leo? Where is it again? It's like within view or something? So how far away is it from us again? Where is it?
75,000 light years.
I feel so protective of it now, knowing but it's when it says it's something about Leo, does that mean we look to the sky, the galactic part of the sky that's Leo, and that's where people are noticing it? Yeah. See, I'm learning through these episodes. I know it's going to take me a long time to learn, but like it's kind of neat to learn along the way. Like I didn't know a lot of this stuff, and I didn't understand some of this, and then after we go through all this, I'll become like into astrology instead. It'll be great.
At the end of the last episode, all of our viewers get a PhD in astronomy.
That's astrology. Like we all just go the opposite way and piss Brad off and become astrology nerds instead. Like, what do you think? We start doing each other's astrology charts, and like Brad just like is shouting into the void. All that was for nothing. What do you think? No?
No comment.
Okay. Galaxies may be connected by cosmic webs, filaments. I really like the word filaments of dark matter and gas. Again, filaments of we don't know and gas. Spider webs of star cities. You know. But galaxies may be connected by cosmic webs. So wait a minute. So matter and gas. Okay. Is that trying to say like maybe that galaxies? Okay, we already know Andromeda and Milky Way are on the way to meet each other in about 5 billion years, whatever. But like, are galaxies maybe connected to each other somehow? Is that like a theory? Is that like a maybe we are kind of
I feel
like
like you just read it, so maybe
yeah,
it's a
but
theory?
like, how are they? Why are they deciding? Are they trying to decide it because of the
They
pull
don't
of
decide
gravity?
things, they observe things and try to explain it.
So how do they think that every galaxy could be connected to each other somehow?
Maybe they're seeing very faint trails of stars that might lead over there. It's like, hey, we kind of see this tiny wisp of star matter. That's, it's not just like a tail on Andromeda or.
I read something about tails in my notes. I'll get to it later. Jellyfish trail. It's kind of interesting you say that. Well, that's interesting. So everything's connected, man. Whoa. I'm kidding.
It's complicated observations because it's kind of like because the time scale that we've been looking at things. We've only had really powerful telescopes for like 100 years.
A decade. It feels like we're just getting them now, honestly. But yeah. Right.
Well, I'm talking about powerful telescopes to like look out and actually check this out. Like Galileo was using telescopes. That was 400 years ago.
But now why? When you say Galileo, it just makes me want to go Galileo. Sorry, Bohemian Rhapsody. Anybody?
No, I'm talking about the Italian guy, not the song.
I know what Bohemian Rhapsody. Now we got to sing the whole song. Can you do the thing?
And that's how you get copyright struck.
Too soon.
Anyway, telescopes have been around for hundreds of years, but really powerful telescopes have only been around for about 100, and we've only like really been better at understanding what we're looking at for maybe 20 or 50. Mm-hmm. We're more certain with what we're seeing. We're not just kind of looking up and like, wow, look at all this stuff. I don't know what it is or what it does. Maybe it's this. We're getting better at it. But of course we don't know everything. The universe has been around for almost 14 billion years, and we're seeing evidence of its early life when we look out there. So to be kind of like there's a highway traffic cam of a car accident, and you randomly take 2 seconds of the middle of this 10-minute video and try to figure out the whole accident that happened. Like, you can't. But we're only looking at this very narrow slice of time in the universe. So we're trying to figure out where galaxies are moving, how do stars get created, what's the fate of the universe, like all of this based on this very small window of observation and understanding. And I think we're not doing that bad.
Yay.
But a lot of it could be wrong, right? We might discover something in 50 years that's like, okay, all that science you guys had in the 21st century, you guys were like totally like way off the mark.
We were dumb. Yeah, because we've been not dumb, but we were wrong before.
But that's how science advances, though.
Yeah. By proving and disproving the theories.
Stuff we didn't understand in the Dark Ages was like, well, a witch did that and just burned her at the stake.
And now we know witches did that. I'm kidding. Sorry.
Yeah, now we have witch detectors. Duh.
Yeah. So now we know.
It's called the Geiger counter.
Oh gosh. Okay. No, is it what?
No. Maybe.
Okay.
Maybe if the witches are radioactive.
Wait, we're not. Witches are not radioactive. Just so you guys.
How do you know that? She's a witch! That sounds like something a witch would say.
So, I love it. Some galaxies rotate backward. NGC 4622 has backward spiral arms due to and it's guessed it could be due to past collisions or tidal interactions. gosh, my
Yep.
writing. What about
Brad,
this? What about a
Brad eating out and
backward?
stuff.
What about this backward
What does
galaxy?
it mean? What does it mean backward?
I don't know. It says it's rotating backward. Have you looked up NGC 4622?
Not today.
Well, I think you
Hold
should.
on.
Have you checked in on NGC 4622?
Yeah. Sorry, all you South of Galaxies out there. I'll be right with you. Also known as the backward galaxy, is a face-on unbarred spiral galaxy with a very prominent ring structure located in the constellation Centaurus. The galaxy is a member of the Centaurus cluster.
Centaurus. Oh my
You
god, how
mentioned
many
the Virgo
suns is this?
supercluster.
Yeah. Please go on.
No, I was going to say, you mentioned the Virgo supercluster earlier. That's
part of the Centaurus?
no, that so. Like you just said about like galaxies might be connected by wispy filaments of stars and things like that.
Mm-hmm.
The estimated structure as we keep zooming out, like, okay, leave the solar system. Oh, the solar system is a group of stars in a spiral arm in the Milky Way, and then zoom out. Okay, well, the Milky Way is one of a group of galaxies called the Local Group, of which there's like, that's like 3 or 4 large galaxies and about a dozen small ones, like the Magellanic Cloud and the Sagittarius dwarf galaxy. And then you just keep zooming out, and galaxies form these like clustered regions, kind of like rivers of stars, and outside of those rivers of stars is just like absolute nothingness for hundreds of millions of light years. But these groupings of these areas of galaxies are named for where like the clumps seem to be when we look out into space. So the Virgo supercluster seems to be in the direction of Virgo. The Centaurus supercluster is in that direction.
Oh.
It's just weird because we're inside the solar system, inside the galaxy, inside the supercluster, and trying to look out and guess what the shapes of these things are.
Oh no, you put Shape of You in my head. Oh my god, remember that song? I gotta add it to my Spotify list. Yep.
That's what you get for listening to popular music.
Look,
just don't do it.
I'm gonna do it. It's gonna go in my
spiral structure.
Shape of You. I got a comment in the
okay.
Yeah, I got.
Well, there's a question in the audience.
Yeah, there is. But I'm still putting it in my on repeat. Shape of You by Ed Sheeran is now in my list. Okay. Sandra Little, welcome to the chat for the space episode. A few vids have popped up lately about us living inside a black hole. If this could be true, then since we can see other galaxies, then black holes are big enough to house multiple galaxies possible. First of all, I'm going to address that first before I give it to Brad. Because I saw a video on TikTok. There was like this lady. She's like, first of all, at the beginning of the episode, we talked about how our Milky Way has a black hole in the center of it. It's Sagittarius A asterisk. Okay. There's a black hole in the center of our galaxy. There's a black hole generally in the center of every galaxy. That's kind of the consensus. So we have a black hole in our galaxy, in the Milky Way. It's called Sagittarius A asterisk, okay? There was a video I started to watch on TikTok yesterday. I know TikTok, but TikTok has some great stuff too. And this lady's like talking about what you're just saying. Oh, that we're actually inside a black hole, and that we're actually, blah, 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 blah. And then she said, my guides told me, and I'm not against guides. I'm kind of a bit witchy woo-woo tarot card thing myself. But let's go to science now. This will take some Brad typing and some Brad answers, because I want to know if this is just some, we're back to Men in Black, we're inside a marble, blah, blah, blah kind of idea, or is this a thing? So I'll read the comment again for Brad. And first, I want to say, I'm not jumping to saying we're inside a black hole, because honestly, maybe we don't know. Like, we've theorized in past episodes about how we don't actually, when we've gone in the sci-fi realm, which we do rotate back and forth between like sci-fi and facts, right, between our episodes, the concept, the idea, the vastness of it all. I mean, we've speculated about what could be in a black hole. We have past episodes about black holes. We started off with black hole. We've talked further about black holes and worm. I think we discussed wormholes as well. But yeah, I don't yeah, because of the Meridian black hole. Thank you, Buddy Bud, for mentioning that. Shout out to Hell Divers too. So, Brad, what do you think about this? I'll reread it again, and I'm looking forward to your angry typing. A few vids have popped up lately about us living inside a black hole. If this could be true, then since we can see other galaxies, then black holes big are then are black holes big enough to house multiple galaxies? You can break that down into a few theories if you want, Brad, or science stuff. I'd love to hear your answer about it too. I know it sounds a bit weird, but honestly, I am seeing a lot of people talking about this. In fact, I could actually...
It's trending? You could say it's trending.
It's kind of trending, yeah.
Ugh, I just died a little on the inside.
Yeah,
I remember there was a Curtis Kazak video with that.
There was a what video? What? Wait, what?
Curtis Kazak does that YouTube channel that I reference a lot because it has a bunch of weird, like, very good explanations about crazy sci-fi topics. Like, why can't you just nuke a black hole? And what's the Kardashev scale like? This black hole could be bigger than the universe, is the name of the episode. I'm not going to watch it. I'll link it later. The idea that we might be living inside a black hole is fascinating. Speculative.
AI immediately said no. Sander, AI isn't even on your side, and AI loves to believe in stupid shit. AI is like, no.
It is based on the observation that the size and mass of our observable universe are such that it could potentially form a black hole, and that the idea that universes could be born from the singulars is black holes.
I want to look at this though. I want to see why this is. So many people are saying no. We don't, but also we don't know where the solutions may lie. Sure, we probably don't live inside a black hole, but perhaps research in that direction may give us a surprising clue. The ideas are worth keeping around. That was 2025. Does our universe exist inside a black hole?
That's this year.
Challenging long-held assumption is essential to scientific progress. A team of scientists is proposing a bold alternative to the Big Bang Theory, suggesting that our universe may have formed inside a colossal black hole residing in a larger parent universe. That is from 4 days ago, Scientific American. I'm going to open this up for you. I'm going to entertain you a little bit because this is trending, and that person was like, my guys told me. No, you probably just saw it trending. Do we actually live inside what's inside a black hole? The answer is no one knows, because we talked about that previous episodes about how, what is that called again? The event horizon? We don't know is our universe trapped inside a black hole? Okay. Here, we're getting closer. We're all living in a black hole. BBC Science Focus. We are going to see why some physicists think we're living inside a black hole. Okay. I'm like, Brad can answer this, and then I totally took over. I'm sorry. When hearing it says Sander Little, then it just seems almost like a fantasy thought that a black hole can house galaxies and even our own universe. This has been up with Neil deGrasse Tyson and others as well, or N. deGrasse. I don't know if you meant Neil deGrasse Tyson, but cannot remember the
other
answer.
One.
I don't know. He said N. deGrasse, so he might have not. You know what? I like I said, because I only heard it on TikTok.
The other deGrasse Tyson name that talks about astronomy and physics.
Why
and shit
some
like
physics thinks we are living inside a black hole. This is from an article published May 8th, 2024. According to a theory, we are encoded at the edge of a black hole in a much larger universe. Because this is where they're talking about two-dimensional and blah, blah, blah. Hawking are going to a paradox. Yeah, like Neil deGrasse, it's Neil deGrasse Tyson, Sander. But yeah, I get what you mean. And Brian Cox, there's that name again. Okay, the paradox. If a black hole can evaporate a portion of the information... Okay, we've already gone over that in previous episodes about black holes. Okay, we're not looking at that article. We're going to look at this other one, Science Focus. We're all living in a black hole. The bold theories scientists can't disprove. from Science Focus, BBC. When is this? Uh, September 13, old news. This September 13, 2024. So perhaps if we calculate the size of a black hole with mass and energy, blah, 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 we get a surprising result. It's almost the same size as the observable universe.
That's why. That right there is why this theory is like stupid. Out there. No.
So a black hole with the universe's radius would have roughly the average density we observe in the universe. The universe has other similarities with black holes. For example, if we run the universe's expansion backwards, it's clear that it began with a singularity. Ooh, I love singularities. You know, there's a singularity tier in the memberships. Thank you. Shout out to Hadu for being in the singularity tier. But Buddy Bud, your cappuccino tier is special too. The Big Bang, okay. A point in time with densities, blah, 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 blah. This is mathematically the same as the singularities in black holes. Black holes also have event horizons, beyond which all light and matter is trapped. The universe has something similar, the cosmological event horizon, beyond which we can't see because light from there can't reach us. And mathematically speaking, the properties of space outside of a black hole's event horizon are simply an inversion of those within. Other studies have suggested that the creation of a black hole can produce baby universes, but despite these theoretical oddities, none of these ideas has resulted in a testable prediction or any observable evidence. Hence, the question of whether we live inside a black hole can't yet be answered. So people have been asking this for a couple of years. Let me go more recently. Sorry, we'll get back on track. So this is March 13th.
Maybe in the future I'll be able to answer.
Yeah, in the future you totally can answer. I just want to get these articles out of the way. March 13th, 2025. Is our universe trapped inside a black hole? This James Webb Space Telescope discovery might blow your mind. I think that the simplest explanation... the simplest explanation, this is from space.com, of the rotating universe is the universe was born in a rotating black hole. Yeah, but we already knew that. Are they really saying something new? Like, we already knew that stars and the universe was made from black hole anyway. So, like, it doesn't mean we're in a black hole. But isn't that what we've speculated already, that stars born of... Anyway. Oh, whatever. Oh, I don't know. Without doubt, since its launch, the James Webb Telescope has revolutionized our view of the blah, blah, blah. Okay. $10 billion telescope, we get it. Early galaxies, blah, blah, blah. Okay. In a random universe, scientists would expect to find 50... Oh, this is the stuff I found out. In a random universe, scientists would expect to find 50% of galaxies rotating one way, while the other 50% rotate the other way. This new research suggests there's a preferred direction for galactic rotation. Okay?
The universe is right-handed.
Yeah. The observations of 263 galaxies that revealed this strangely coordinated cosmic dance was collected as part of the James Webb Space Telescope Advanced Deep Extragalactic Survey, or JADES. It is still not clear what causes this to happen, but there are two primary possible explanations. One explanation is that the universe was born rotating. Rotate on this. That explanation agrees with theories such as black hole cosmology, which postulates that the entire universe is the interior of a black hole. But if the universe was indeed born rotating, it means that the existing theories about the cosmos are incomplete. Born in a black hole cosmology, the space.com article says, also known as Schwarzschild cosmology, suggests that our observable universe might be the interior of a black hole itself within a larger parent universe. The idea was first introduced by theoretical physicist Raj Kumar Pathria, I'm sorry if I'm mispronouncing anything, and by mathematician I.J. Good. It presents the idea that the Schwarzschild, why am I thinking of Schwarzenegger, radius, better known as the event horizon. What? You never told me the event horizon was also the Schwarzschild radius? Brad? Keep things...
Schwarzschild... Whatever.
Keep
going.
No.
Out of
the boundary from within which nothing can escape a black hole, not even light, is also the horizon of the visible universe. This has another implication. Each and every black hole in our universe could be the doorway to another baby universe. These universes would be unobservable to us because they are also behind an event horizon, a one-way light trapping point of no return from which light cannot escape, meaning information can never travel from the interior of a black hole to an external observer. This is a theory that has been championed by Polish theoretical physicist Nikodem Poplawski of the University of New Haven. New Haven is a planet in Helldives 2. Black holes are born when the
It's a
core.
city in Connecticut.
Oh, well, there you go. Okay, so in his theory, eventually the coupling between torsion, the twisting and turning of matter, and spin becomes very strong and prevents matter from pressing indefinitely to a singularity. Okay, this is a great long. This is okay. Okay, Einstein, the Einstein-Rosen bridge. Okay, wormhole. Okay. So this is a long article, but I can't read it all. But another explanation. Let's go to the end. TLD didn't read. Is that the Milky Way's own rotation could have caused it, for why they may have seen an overrepresentation of galaxies rotating in one direction, is that the Milky Way's own rotation could have caused it. Previously, scientists had considered the speed of our galaxy's rotation to be too slow to have a non-negligible impact. If that's indeed the case, we will need to recalibrate our distance measurements for the deep universe. The recalibration of distance measurements can also explain several other unsolved questions in cosmology, such as the differences in the expansion rates of the universe and the large galaxies that, according to the existing distance measurements, are expected to be older than the universe itself. Okay, so what are they ultimately saying there? Black holes form from stars at the centers of galaxies, and most likely globular clusters which all rotate. That means black holes also rotate, and the axis of rotation of a black hole would influence the universe created by the black hole, manifesting itself as a preferred axis. I think that the simplest explanation of the rotating universe is the universe was born in a rotating black hole. Space-time torsion provides the most natural mechanism that avoids a singularity in a black hole and instead creates a new closed universe. A preferred axis in our universe, inherited by the axis of rotation of its parent black hole, might have influenced the rotation dynamics of galaxies, creating the observed clockwise counterclockwise symmetry. What? So what's going on here, Brad? I didn't get all the articles. Tell me what's going on here.
What?
What's going on?
Which part of all of that do you want me to explain?
I want to know what's going on. Why are people freaking out about that? What is this?
People think that the entire universe might be in a black hole because of all that shit you just said?
Yeah. There's more, so yeah.
I feel like some of it is we have an idea and we're going to use the science we understand to rationalize that idea. It doesn't make it true. It can make it possible. But that's kind of like the hey, this rock keeps tigers away from your house. As long as you have this rock, you won't get attacked by a tiger. If you give it to someone that is nowhere near where any tigers live, that doesn't mean that's what the rock is doing. But they might believe you. Well, so based on our observations, yeah, all of that stuff might be true, but it doesn't prove anything. It's just it's a theory.
It's just a theory. The new study explores the idea that the universe may not have begun with a singularity, but instead emerged from the collapse of a massive cloud of matter in another universe. They're running simulations.
That's part of the big crunch theory, where the universe will end by all the matter eventually smashing together again. And the epilogue of that is, well, maybe if it smashes together, it'll create this crazy huge explosion to make another universe.
Yeah, under the right conditions, this collapse doesn't end in a singularity. Instead, it bounces and begins expanding again. That bounce mimics what we call the Big Bang.
Yeah.
I don't know space.com if you're very reliable, but I'll share it anyway in the research labs. Kind of off topic, but
I do like the idea that the I guess the analogy to what they were talking about, where the observable universe has is kind of like a visible horizon, kind of like the inside of an event horizon. So we can't see outside the observable universe, and you can't see inside of a black hole. It's like, whoa, are we in a black hole?
Yeah.
It kind of, I can see why that makes sense.
Mm-hmm.
Well, there's other videos that talk about that. It's like, wait, if the universe is literally the definition of everything in space and time, but there's an observable edge of the universe because that's how far we can see, what's outside the edge, and what do you mean outside the edge? How can there be an outside of everything that exists? That doesn't make any sense. So, of course, we can't... There's no way for us to prove any of that yet. Because it's not like we're going to get to the edge of the universe with a spaceship to start investigating anytime soon.
Yeah, because,
So it's an interesting...
it has been
it almost
trending.
gets more it gets more into theology almost because we're talking about the entire universe as a whole and its ending and all of that. We can't really even come close to defining it with science with certainty.
Just to answer
But
the
it makes
question,
me
I
think
say after
about
talking too long. I'm just kidding.
it makes me think oh like you just did. It makes me think about how
Exactly.
the atomic
Say,
model of electrons orbiting an atomic nucleus
mhm.
is kind of exactly how planets orbit a star in a solar system, and one is hundreds of millions of miles across, and one is so small you need powerful microscopes and things like that to even see them at the atomic scale.
I just shared a
So that
bunch
kind
of
of
those articles in the research lab part of the um, Discord, guys. For Sander, you inspired me to share that stuff. So, what do you think then? It's a theory that they're like what been studying for a few years now, and now it's being talked about a lot more. Like, whoa, we're. Does that change anything? Does that change anything if we're in a black hole?
deep.
Because we speculated in the black hole episodes. We don't know what's in there. We even, I think, on one of the episodes said there could be life in there. There could be things in there,
Yep,
knowledge things.
it could be a region of space that's habitable. We just can't see it to prove anything. They could, because space time gets so warped, it could be some kind of like black hole leads to a white hole, and the black hole pulls things in, and actually it's like there's a white hole fountain somewhere else that's spewed all the stuff out,
But what if it's just
and
like
you can
what
turn
we're
that into a
living in?
wormhole with certain energy.
What if it's just another universe like these? Like where we are, a bunch of galaxies and universes. Just why are black holes so.
I guess that begs the question: do you think that? And this is not like a scientific question. Like I said, it gets more into the belief and theology and what you think because we can't prove it. But does that suggest that the black holes that we can observe, even smaller ones like Cygnus X1 or large supermassive black holes like Sagittarius A star,
The one that's at the center of our Milky Way?
do you think there is another universe inside of that?
Whoa, that'd be trippy. What if there is? What if black holes are
Which
just
could be
things
like
holding
maybe
universe, a baby universe, like it was saying? And it's like that whole within that, and if it's got a black hole in it, there's more universes within that one. What if black holes are as important and trippy as gravity?
that would make sense because they're almost entirely gravity.
That gravity episode is going to be mind blowing. So I'm telling you, okay, so if black holes are that important, because when we're talking about galaxies in this episode, which the episode is about galaxies,
Mm-hmm.
we already stated that Sagittarius A asterisk is the black hole at the center of our galaxy, and that most galaxies have a black hole. Pretty much all of them. And I think I thought there was only one that might not have. I don't remember if I saw that in my notes that we know of. We just can observe it or whatever. That
We can't
they all
prove it
have
yet.
black holes. Yeah, they all have black holes. And if this thing is that we're in a black hole and the black holes, like if we're in a black hole universe and then we have black hole in our universe, in our galaxy, and if that black hole has its own thing and it's just, I mean, wow, that really throws your whole God created the earth 2,000 years ago thing way out the window, doesn't it? But no, like,
A
could
lot
you
of science
imagine?
does. Yeah, you're right.
Yeah. I mean, I think I'm going to stop believing in flat earth soon. I'm just saying, like, I mean, I get why people are excited about it, but wow, could you imagine how we could ever
It's a
conceive
theory
of
that we
that,
can't prove, but I think the best thing about it is that it gets people thinking about astronomy and science and physics.
right? Well, if they are trying to look at this from a, like if they're trying to prove it somehow, I mean, like eventually we got to get to that point where we're interstellar, where we have some cowboy hat looking guy going through the, or woman or whatever, anybody going through to the event horizon. We gotta know. We gotta know what's through the black hole. We just have to know. Because that would be trippy if instead of it being all that what was in the interstellar, you just entered another like galaxy. You're just in another galaxy.
You're in another universe where everything's 8-bit.
No,
Whoa.
no, it's not even like that. That's just another galaxy like we're in. Like it's
How do you
another
know?
different galaxy. But
Maybe
could
it's
you
all 8-bit.
imagine? Yeah, maybe. But what if it's just like these like what we've observed, right, of other galaxies, right, which we
I
don't
think
know,
that's the
stars and
multiverse theory.
stuff. I know, but
That's literally the multiverse theory.
we've observed other galaxies, right, that have stars, dying stars, blah 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 blah, right, and within
So
here,
scientific.
yeah, I mean, that's what I'm known for, and so like what if that's all it is? Just repetitively another black hole with more stars and nebula and planets dying and stars dying and all that stuff. It's just, it's not that trippy.
That's
We're just in
that's the idea of
pocketed
the infinite universe. Is there's different explanations for how it just goes on forever. Maybe it's a universe that doesn't end. Maybe it's
song
a
that
universe
doesn't
that has an
end.
edge, but it
Sorry.
has black holes in it that leads to other universes, which might be very similar to ours,
What
or they
if we
might have
did
totally
learn?
different parameters. Like it enters a universe where there's 2 dimensions of time and 1 dimension of space. The
Red
hell would
Dog.
that be like?
Red Dog said, "Oh my God, what a crazy space news today! What's your space news, Red Dog? Or are you talking about what we were talking about? We were just on a tangent. What, Red Dog? Share with the class. Well, that was an interesting side quest. What do you think about it, Brad? Overall, what do you think of it?
Well, it's an interesting idea. Like it's I don't know how. Like we can't prove it yet. Um, I'm
I wonder why it's picking up steam
I'm
right now when it's been
I
talked
like the
about for a few
idea
years.
of because that's how social media works.
Oh yeah, you like the
I kind
idea
of
of
like more the idea of um, black holes being like tunnels through space and time. Whether they contain entire other universes, I don't know. I think it's more like that weird scaling symmetry. Like, oh, the atomic nucleus is like a solar system, so maybe we see the universe kind of has like an event horizon sort of thing, like black holes we observe do, but it's just analogous. It doesn't mean that we're inside a giant black hole. Could be though. Like I said, there's no way to prove that at all.
Hey, Red Dog, have you thought of sharing that in the uh, in the space news or the space pics section of the Discord? You could link that there
What's the
for
space
us.
news?
He says it's in our galaxy. Definitely not to. Okay, the James Webb Telescope just discovered an exoplanet with a friggin' picture. This has never happened before. Yeah, you should share that in the Discord in the Space News or Space Pics section of the space station, Space Hub. That'd be wonderful. That is exciting. That is exciting. You just drop the link in there of the image
You can
or the
do it.
image. Yeah, please. Then you can share with the class. Redox says, "Here's why this is insane." Well, he says, well, he's going to drop the link in the Discord. Yes, in the space section, right? We normally discover planets by watching how things like suns interact with gravity, right? It's basically all math. Red Dog is
Yep.
going to tell us. Yep.
Or the transit method. But yeah, direct photography would be fucking crazy.
So share
Like
that.
we've never had a telescope that is that good at that.
Apparently, James Webb has. So
Yeah. Well, it's the newest telescope we have that's in space, so it should.
but today they announced that JWS just saw an exoplanet. Sorry, discovered. Okay, so do you have the image and link that you can share in the Discord, Red Dog? Please share it in the space news part of the Discord. Please share it in the space news part of the Discord for me, please. And I have to pee, so I'm going to have a quick break. Well, Brad. tells you stuff about things and whatnot. I don't know.
A
No,
couple
I
of planets
don't.
to
No, I
scan.
don't. What? No, you don't.
What?
What?
I'll get it. I'll get the link. Hold on.
You'll get it. Okay. Well, Brad will talk to you guys about that while I take a quick break. I'll be right back, guys. I'm sorry.
It's kind of cool, though. I like the idea of, like I said, Red Dog, if everything's been kind of indirect observation, like, oh, we see this star, and then every once in a while it gets kind of dimmer, but like there's a pattern to it, we infer from that there's a planet getting in the way, and we're like, oh, well, there's got to be planets there, because it keeps happening, and what else would it be? But the idea that we could have a telescope that's good enough to just literally take a picture of it. James Webb Telescope has discovered an exoplanet by directly imaging it. Yeah, there we go. Okay. This might be like the picture that we took of the black hole in the center of a galaxy. It was a weird, like, false colored image because it was all red and orange and stuff. But oh yeah, look at that. Okay, I'm gonna send the link to Discord. Okay, so for the first time ever, the James Webb Telescope has discovered an exoplanet, which is the term for any planet that we discover outside the solar system, by directly imaging it. The newfound world has a mass roughly similar to Saturn and orbits inside the debris disk surrounding a young star named GWA7. So the debris disk, I guess this must be a very young solar system where there's either still a lot of like leftover material from when the planet's formed, or it's literally still happening as we observe it. James Webb Space Telescope has previously discovered more than 100 planets, mostly through the transit method, which is that method I just talked about, where you literally see the planets go in front of it, but it dims the starlight, kind of like someone walking in front of a campfire on the other side of a field. And you're like, hey, the campfire's getting dimmer. What's going on?
I missed that you shared the link, huh?
Yeah.
Is it exciting?
Yeah.
Yeah, so Red Dog's, I can read Red Dog's comments then. An exoplanet today with a picture. Okay, but this is like taking a picture of a fly at night. Red Dog says. I wonder if he's basically saying what you said, Brad. I missed it all, but I'm guessing you guys said, picture of fly at night on a car's headlight, but the James Webb Telescope is able to cover up the light, and that's how they saw this Saturn-like planet. We can actually see planet with cameras. That is so incredibly exciting, Red Dog says. No, like you explained, we have two viable ways to discover planets now. Now, like you explained, we have two viable ways to discover planets now. Red Dog is pretty excited. There you go.
Yeah, it's close, too. It's only 111 light years away.
Wow. So now we have, like you were saying, we couldn't take pictures before because of the light, all the light of the thing. Now we have a way to, like, figure a way around that? What did I miss? Oh, I wish I would have taken you in the bathroom with me, but I didn't want to do that. So
yeah, please don't. I was just reading a little bit about the paragraph of the link. For the first time ever, the world has discovered an exoplanet by directly imaging it.
So they can direct image it. How?
Well, like Red Dog's saying, it's the like camera and imaging equipment on the telescope can actually see it. We're not observing behavior and making guesses, no matter how educated, of like, oh yeah, there's probably a planet there based on everything we're seeing. We're actually seeing the planet, and like you said, it's like
this means we'll be able to see viable, like whether it could be viable life eventually stuff, right? Like this is like the idea of we could probably enhance and then decide like that looks like it is similar to a type of. Doesn't that mean like more implications than just seeing the planet?
Eventually, a lot of it's still inference, though. It would be we could
infer better though now.
We would infer data and things like that. Like, it's such and such a star type. We can assume based on observations that the planet orbits at this distance, based on the math we know about the inverse square law on like heat loss over distance would mean the planet is probably this temperature, unless it has a crazy atmosphere or it has no atmosphere. But if it did, it might be this temperature, and if there was water there, it would either be frozen or vapor or liquid, depending on what the temperature is.
I'm exciting.
But that's science we kind of understand. So as long as we make accurate observations, we can make good guesses at, this planet is probably a terrestrial planet, not a gas giant or anything like that, and it probably has liquid water on it. So even if there's no life there, it might be somewhere that humans could live in the distant future.
That's exciting news. And
humans might live on this planet someday.
There you go. And you got to see a picture of it. Red Dot, and you shared that where did you share it? In the news part of the Research Hub?
Space News. After the space weather and space
traffic. Is it
traffic.
In the Space News? Or in the Space
News.
Fantastic.
It's not a picture, it's news.
There you go, guys. Space News. So if you're not already in the Oh No Discord, it's not just for health divers and stuff. It's also got for the Let's Discuss broadcast. Yeah, you got a space section. And you guys can post in the Space News. Yeah, Red Dog. And I'm going to read the rest of his comments. He said, imagine taking a picture of a fly on a headlight from a mile away, but this camera can block out the light and see the fly. Right, we see it. It's not math telling us where to look and measure. We actually just looked up that for the first time and saw a planet outside our solar system. Red Dog's pretty excited. We saw a planet outside our solar system for the first time. We already know this planet's temperature. It's about 100 degrees Fahrenheit, and it's about the same size as Saturn, says Red Dog. That's some really fantastic space news this week. There you go. So we're not even done our topic yet. We've had some exciting space news, and we've also discussed the idea that we're in a black hole.
Breaking space news.
Yeah, that was great, Red Dog. That's fine. I appreciate guys. I also appreciate the on-topic stuff too, but it's good to have some ponderings that lead us on tangents as well. It's still, you know what I mean? And that was perfect timing because I really had to pee. So thank you so much. Okay. So.
What other galaxies? Did you want to talk about the shape of galaxies?
I got more galaxy stuff. Yeah, I got more galaxy stuff. Okay. We got more than just shapes of galaxies. Okay.
I know, but we were still kind of not done talking about that.
Oh, you're not? Well, if you want to keep talking about that, you can.
You said
nothing more to say. Buddy Bud asked that. No, I had nothing more. I'm moving.
Okay, so what did Buddy Bud ask?
That's all he asked about. He wanted to talk about shapes of galaxies way back when. And what was the comment? I thought we did that. Let me look back up. Buddy Bud, can we talk about galaxy shapes a bit? And do you think the shape of a galaxy affects the likelihood of forming life? That's what he had asked.
Oh, yeah, right. Yeah, we did talk about that.
Yeah, we did. That's why I was moving on.
But the shapes themselves, there's elliptical, which is kind of oval or egg-shaped. There's spiral, which is like a pinwheel like our galaxy or the Whirlpool galaxy. And then there's barred spiral, where it's a spiral but not all the way to the center, and somewhere in the circular kind of shape, it stops being like a spiral into the center, and there's just like it looks like a bar, like a spoke coming out of the center, and that's where the spiral arms start. So imagine those spinning little fireworks where it doesn't spin from the center. There's something spinning and shooting sparks of fire and stuff like that out of the ends. And the barred spiral kind of looks like that. And there's, I don't remember what the term is, but there's basically degrees of how large the bar is compared to the diameter of the galaxy. So you can have bars, I think the Milky Way technically has a bar in it. It's called the 3 kpc bar.
Well, tell me more about that.
What? Covers $10.
Oh, you're telling a joke.
No, well, that was a bad joke, but there is something called the 3 kpc bar because it's about 3 kiloparsecs from the center. That's what the KPC stands for.
Oh, okay.
And it's a relatively short bar shape, and then all the spiral arms kind of come off the end of that, but the bar goes through the center, kind of like an axle.
So galaxies have arms that are reaching out to other galaxies, which is where the tendrils of connection are possible. When
so
they
reach out, but they have no legs, so they can't run away.
Oh. That's galaxies get more isolated over time. When you look at a galaxy, you're seeing how it looked millions or billions of years ago. It's like a time capsule of the past. So our galaxy is right now. But if our galaxy is observed by somebody, okay, here's a question. If our galaxy is observed by some other people and some other, or whatever, beings in another galaxy, they can observe us.
It depends on how far away they are.
But if we're right now, we're not in the past. But if they can observe us, they can't. So can they not observe us until we are already gone? Can you only observe galaxies that are already gone?
They wouldn't already be gone. It depends on how far away they are.
Okay, so let's say they're very far away. We're already gone then. If we're not very far away, then what does that mean?
The closer things are in the universe, the more likely they haven't changed much since we saw them, or since we can see them.
Okay.
That's like the Betelgeuse star, where it's like, it's 600 light years away. It could have gone supernova already, but the light takes 600 years to get here. Mm. So maybe it went supernova 20 years ago, and the light's still 580 light years away. So in 5 centuries or so, we'll be like, whoa, what's going on over there? Mm. So if there's a galaxy, like from Andromeda, for example, if there's a sentient race in Andromeda, like the Andromeda Galaxy, looking at the Milky Way going, hey, what's going on over there? They're looking at the Milky Way as it was 2.5 million years ago.
So okay, so they're not seeing that we're even here yet. Oh my god,
no.
oh my god, oh my god, oh my god, oh my god. So we're not even here yet. They're looking at the past of us, right? And we are the past, Pastafarians. Shout out to the Pastafarians out there. Does anybody remember that being a thing? I'll get to you right in a minute, Red Talk. So then, okay, so if we're seeing galaxies, we may not know that they have life because we're seeing old stuff, right? Old images, right? Yes. So they may already be developed as well. We don't see that because we're seeing like what it looked like millions of years ago.
That's a two-sided answer, though. One
thing, goes both ways.
No,
unless they have better technology. No. What if they have the technology to be able to see currently, even if we are far away? We just haven't figured out how to see.
Then they're basically time traveling.
What if they can? Because what if it's just about advanced technology that goes, oh yeah, those stars are billions of years ago, but like we can see what they look like now just because of our technology.
So how do you think that technology would work?
Time travel, obviously.
That's not a real answer.
I don't know, but they'd have to figure something out. They'd have to know. Because wouldn't that be a problem for an advanced civilization to go, yeah, that's great and all that. I can see what the stars look like billions of years ago. But I kind of want to know what that freaking galaxy is up to right now, because clearly if it still exists, I want to know. Because let's say I want to go like take it over or mine it or develop it or whatever the hell they want to do, or see if there's other life there, if it's plausible to go to that galaxy and move there, whatever. If they're that kind of like advanced, let's say we're believing in that, or if we got to that stage, not us in anytime soon, we're nowhere near anything like that, but if we got to that, wouldn't we want a technology that can figure that shit out? And when we, like, even if it's an AI super advanced model that would be able to tell us what's there now?
We would want to see what we're going to colonize or explore.
Yeah.
Before we get there, yeah. It's kind of like reconnaissance.
Yeah.
But that doesn't mean it'll be physically possible.
Well, it might not be, but we don't know.
We want to see what's there before we get there? How do we see that? I know. I don't know. We don't know yet. But like obviously we're very aware that what we see is from the past. And obviously unless the other people, they're seeing something from the past, right? They would, yes.
That is so fucked up. So are we
the other thing is even
so
if
are we in the past? Wait.
No.
Okay, hold on.
So even if they could see, even if say we had technology that went faster than not so
time or
much
light or
vehicles,
anything.
not so much vehicles that go faster than light, but like radio signals and things like that travel at light speed, essentially. Mm-hmm. So radio signals that were broadcast 50 years ago are now 50 light years away. Mm-hmm. But because of signal degradation, that doesn't mean people that are 50 light years away are like hearing clear as day, radio broadcasts and television signals. It's all garbled and messy. It's just, from their perspective, it's just something that's like, this isn't like natural background noise, but we can't understand it. And that's not like I'm not talking like alien language thing. It's more like it's so degraded, it's an unintelligible signal. Kind of like staticky radio and stuff like that. It's like, yeah, I can detect something, but I can tell it's not, like it's artificial. It's like made by a species, not by nature.
Naughty by nature. Sorry.
We don't know what it is.
OPP?
Yeah, no.
Sorry. Okay, no. I got some comments.
Okay.
Sorry. Question, says Red Dog. We got a lot, just so you know. Question. Good. We know that galaxies contain dark matter. We did talk about dark matter earlier. Do you think there could be galaxies of just dark matter? I wonder. That was in my notes. There is one that they speculate is. Red Dog, what asked that? We know that galaxies contain dark matter. Do you think there could be galaxies of just dark matter?
Maybe, but like there'd be no way for us to see them, really. Or that could be things that explain
other dimension.
No, but just like how we've kind of like our observations hint that dark matter exists because we can't explain what's going on. But if you kind of zoom out from that perspective and say, well, we can't explain why these two galaxies, or yeah, the galaxies might have dark matter in it, but they're still behaving weirdly compared to each other. So maybe that's explained by a dark matter galaxy somewhere in between them that's influencing their movement, but we can't see or detect the dark matter. So we're like, well, what the hell's going on? So it could be. Especially since, like you said earlier, like there's some galaxies where we think it's up to 80% dark matter. So wait, there's things that we can observe and study that are 80% of something. I feel like there could be galaxies that are 100% of that same thing. I can't believe it's not dark matter.
I can't believe it's not butter.
And if it acts based on gravity, like most things do, it makes sense that
gravity episode. Go on.
It makes sense that there could be formations in space that don't have like fermionic matter in it that we can see.
Red Dog says, I completely agree. Double exclamation. Now I gotta catch up though. Buddy Bud says, okay, they'll watch this podcast in 600 years, but it'll be too degraded. They won't understand it. Red Dog says, but that's funny, Buddy Bud. Red Dog says, only a certain amount of planets that can see us would know we existed. People are 40,000 light years away, and Neanderthals would be about 200,000 light years away. Whoa.
Based on the time, yeah.
Yeah. Sander Little says, would you not calculate by own evolution so we know how Earth evolved and those stages? So you would look at a galaxy planet and see what stage it is in?
We usually do because that's our only frame of reference. We don't have other planets with life on it or species to compare, so we constantly refer to what was the Earth like?
Yeah.
And what was our solar system like millions or billions of years ago? Okay, it might have been like that everywhere. And until we find
evidence
very good science or direct evidence that it's different, we're going to keep running with the ideas we have. Yeah. But again, a lot of science is basically like that. Hey, this is what we see. This kind of makes sense based on a bunch of like physicists and astronomers and mathematicians and whatnot, like crunching the numbers based on observations. It's like, yeah, that makes sense. The scientific community kind of comes to a consensus. And yeah, we base all of our ideas on that until something else goes, whoa, table flip. All that math you did was based on an incorrect assumption.
On lies,
here's a new math.
Stupidity. Yeah. Yep. Uh, the new math just reminded me of new math when, okay, I'm old, in school when they gave us new math in school. Oh my gosh. Anyway. Okay.
Hmm?
You were too young for that, Brad, but there was like new math introduced
New
when I
math?
was, yeah. So they were calling it new math in high school. We had some new math, some new ways that, anyway, don't worry about it. It's for us old folk. Red Dog would understand.
Okay.
Okay. Red Dog said humans are 40,000 years old, and Neanderthals about 200,000 years old. Any planet further in light years than that haven't seen us yet. I thought you already said that. Okay. Oh, yeah, good. Okay. All right, so we're caught up to that. Can we get back to galactic
Yep.
galaxies? Okay. Galaxies can die when it stops forming new stars and runs out of gas, or what? So if galaxies can die, would our galaxy die? It's not going to as good as
Based
Cloud
on
Andromeda.
based on whatever that statement said.
Mm-hmm. Yeah. Have we
I feel like
evidence of
there's a big
galaxies
difference.
dying?
I feel like there's a big difference between there's a garden that you haven't put any new flowers or vegetables or anything in, and all the vegetables and planet and things there are dead.
Oh,
So there will come a time where star formation stops,
but it doesn't
but
mean
there'll
it's
still be
dead.
billions. There'll still be billions of years where the stars that are currently there are still burning and take a really long time to extinguish their fuel.
It'll just be there. Okay.
The sun's going to be around for like 10 more billion years. That's just
The
our sun.
I know I'm skipping back to some news, but the JWST, that James Webb Telescope, finds a jellyfish galaxy at I don't know, some squiggly line 1.16. Okay. Cosmos 2020 dash, I don't know, something Z blah blah blah. Oh no, 635029. Okay. I don't know. Anyway,
What?
pressure stepping, gas being swept off in long jellyfish-like tails, star formation from galaxy core. So the James Webb Telescope found a jellyfish galaxy. It's called the Cosmos 2020 6350 or 829. Sorry, 635829. Cosmos 2020. Ram pressure stepping gas. I don't know, stop it. I don't know, my words writing. Yeah, but there are jellyfish-like tails off of this. It's a star formation from the galaxy core. It's a jellyfish galaxy. I don't know. That's news. Just saying. Doesn't matter how far they are. Maybe they could detect it. Oh, Red Dog says, so if there's a species that's master quantum entanglement, then we could alert them to our presence with experimenting with quantum stuff. On the quantum level, there is no space or time. Yeah? Doesn't matter how far they are. Maybe they could detect us. Maybe. We're not there yet, though. We're not on quantum level yet.
Well, the quantum entanglement is about on the same level as the is our whole universe inside a black hole.
A theory?
Yeah. And even if it's true, it's not necessary that quanta within our galaxy are entangled with quanta in the observable or the observer galaxy, rather.
Smarty pants. And MOM-Z14, most distant galaxy yet confirmed, observed at redshift. What? I don't know. Something less than 300 million years after Big Bang. It's early galaxy
sometimes this
growth.
stuff gets so far away they just measure it in its redshift value, which is typically like a Z and a number.
Oh, Z minus 1444 or something. Yeah, 0.44. Yeah. So it's the most distant galaxy yet confirmed. And gosh, I wish I could read all this. Discovery of QUIPU. I'm sorry. QUIPU. QUIPU. Supercluster using X-ray ROSAT data It's the largest known structure in the near universe, a billion light years long supercluster complex, weighing in at. I squiggled it out because it was a lot. I didn't want to read it.
Okay, but that was like the we talked about
News.
the Virgo supercluster earlier.
Yeah. Yeah. Well, what's this Quipu supercluster? This was recently
They said it's
found to be the largest
the
known
largest one.
structure. Yeah.
They call it a structure because it's like that river of stars I was mentioning.
Hmm.
You take a group of galaxies and you keep zooming out, and in the emptiness of space, these groups of galaxies are like filaments or rivers of stars.
And then there was my news about the collision was reassessed for Milky Way and Andromeda. We already mentioned that earlier, but data from Gaia, and the Hubble, it says there's a less than 2% chance in the next 5 billion years, guys. So we're okay still. And squiggly line, 50% chance over the next 10 billion years. So we're okay. We're okay for now. There's also a new spiral. It's called ZHULONG. There's some accents over that. It's a full spiral structure. It's been imaged by the James Webb Telescope. That's news. So just so you know, a new
What?
design spiral. It's called the ZHULONG.
Yeah,
It's a full
Zhulong.
yeah. It's a full spiral structure. It's the James
So
Webb
that's a new galaxy.
Telescope. Yeah, it's a new design, new spiral. Yeah, new spiral. Yeah, full spiral structure. James Webb Telescope got it.
So they
It's in the
discovered a
news.
galaxy.
I don't know. It's in the news.
You're reading it.
It's in the news. Yeah, I don't have all the details because I'm reading it on my notes. My notes are terrible.
Oh,
My
okay, so you're reading
Androids.
terrible notes. That's why.
Yeah, but still, if you type it in, you'll probably find it.
Why don't you just save bookmarks then?
Because it's
Anyway,
written in my notebook and it's not Mr. Fancy Pants. And yeah. Okay. I wondered about this, but because we already talked about the black holes, like it doesn't matter. What would a galaxy be like without a central black hole? But now, I guess, I don't know. What would a galaxy be like without a central black hole? Like we have Sagittarius A. I guess we kind of already talked about that. We'd just be around something else. Can you have a galaxy without a black hole?
I think it would be a minor, like a dwarf galaxy, like the ones we talked about.
So it wouldn't be like what we have. So
It
do
wouldn't
we
be a.
need
I
that
don't think
black
it would be
hole?
a spiral.
Do we need that black hole to
What do you
exist?
mean? Like, do we need
Yeah.
that?
Is
The
that
Milky
black
Way
hole?
needs it to maintain its current shape, so yes, in that sense.
So we do need that black hole.
The the Milky
So
Way does to maintain its shape. Yes, it does.
then we
Do
do need it.
galaxies need it? No,
Galaxy don't.
because like the Large Magellanic Cloud might not have one. At least we can't see one.
Well, it is kind of cloudy there. We don't know if we need it or not, says Red Dog. Well, let's find out on the next episode. You can get rid of the black hole. No, we can't do that. That'd be terrible. Um, this is something I literally asked this. Are galaxies part of something larger? Well, I guess we've already talked about that.
Galactic superclusters.
Yeah. So, what do you think of that?
They are, and we've observed them.
Well, tell me more, please. So I'm curious. So galaxies are part of. So this tendril idea. Can you
Like
tell me
the larger structures.
what are they?
Like the Milky Way and Andromeda and Triangulum, and I can't remember the other nearest large one, but like the Magellanic Clouds and Sagittarius and Canis Majoris dwarf galaxies are all part of the local group, which is like our neighborhood of galaxies.
Mm-hmm.
But I think that only extends out to like 10 or 20 million light years. Say only.
Mm-hmm.
The space is ginormous. And then there's other local groups like that where it's kind of like we're in a suburb and there's another suburb maybe 50 million light years away, and in another direction, maybe 75 million light years, there's another cluster of galaxies and minor galaxies. But then you keep zooming out, and these clusters keep like forming, very kind of odd shapes. It's not like it's a rectangle or a triangle or anything like that, but it's kind of like cobwebs or filaments or wisps.
Spiderweb, the filaments, the spiderweb thingy. Oh my goodness.
Yep. But at that scale, they look like large groups, and that's what the galactic superclusters are.
So we're part of a galactic supercluster?
The Virgo supercluster is where the Milky Way galaxy is. Ooh. Okay, I'm done jumping. Hold on a second.
That was a really good explanation of superclusters, says Red Dog. I don't know. I'm still confused. I think he could have done better.
What are you confused about?
I don't know.
So,
I'm just like, I don't know. I guess I kind of get it.
I think you just prefer to be critical.
Yeah.
A galactic supercluster is a massive gravitationally bound structure in the universe consisting of clusters and groups of galaxies, and is among the largest known structures in the observable universe. These superclusters can span hundreds of millions of light years and form filaments, walls, or sheets of galaxies.
Sheets of galaxies. Walls. Walls against what?
Nothing.
How do we know?
How do we know what?
That
what a wall
nothing.
Is?
No. Why would they call it a wall? A wall for what?
Because it's shaped like it's shaped like a flat surface.
Oh, okay.
Open image in a new tab. Yeah, that. Copy image.
Enhance. I'm just kidding. I was sharing a superclusters image in the Discord in the research lab section. Oh, wow. Okay, and we're in there. Where are we?
We're in the middle of the circle.
Virgo? We're in Virgo, but Sagittarius is our... Look at the Leo superclusters. Yeah, I hear you, Smudges. What do you got there? Smudges has a toy, okay, guys? I hope you guys understand she has her toy.
So all of these have their name because that if we look up into the sky, these are the constellations where these clusters are situated. So Ursa Major supercluster, it's in the direction of the Big Dipper.
There you go.
Corona Borealis, it's in that direction. Except for Shapley, I don't know what the hell that one is.
Yeah, what's that about? Can you tell us?
Hercules, Copernicus, Sculptor, Horologium. The second supercluster is a local supercluster. Here's these Z numbers again.
What's Z numbers? Yeah, because I've been seeing a lot of those tonight.
Z equals 0.046.
That's a distance calculator.
It's a redshift. It's a redshift measurement. Yeah.
Now I'm learning that's what a redshift measurement is, and that redshift just means we have no idea it's so far away. Is that it?
I think it's at some point we either can't really define it well, how far away it is, but we can detect its redshift.
And remind people what redshift is again?
Redshift is when the light waves from an object moving away from you are stretched out because of the vast distances, but not because they're far away, but because they're moving faster than the light can kind of get to us. So the light waves are stretched out, and that makes them more red, because in the visual light spectrum, longer wavelengths of light are more red, and shorter wavelengths of light are more blue. Here's kind of a goofy picture, but it describes it kind of well. That's on the wiki page that we were talking about.
Good stuff.
Nope, it's just the same image.
All right. So, oh shit. So I wrote this question down. I should have known somebody was going to come along, and we don't need to talk about it because it said, could civilizations exist inside the supermassive black hole at the center of galaxies? Well, guess what? If we go with what we were talking about earlier, I guess that wasn't off topic at all. Sander Little was right on topic because basically, could civilizations exist in the supermassive black hole at the center of galaxies? Maybe, if we're considering the idea that we might be in the middle, that our galaxy might be in a black hole. Right? Yeah, I guess so. We don't know. We don't know what's in the black holes. And wouldn't that be funny if we're in the black hole as well as having a black hole inside our galaxy, but we also are in a black hole? That's fucking great. Endless black holes, just full of
Black holes all the way
galaxies.
down.
I don't know. Hi, Bruce. It's good to see you. Bruce says, I don't want to know what's in the black hole. Bruce, mind blown, but we could be in the black hole. You'd have to have listened to the earlier part of the episode. We might be in the black hole. Well, also, Sagittarius A asterisk is our black hole at the center of the Milky Way in our galaxy, which is a Milky Way. So, yeah. You might find out that the black hole is in you, Bruce. Or that you are the black hole. I don't know. It's science be crazy like that. Some more shared by Brad in the... I hope you guys are in the... oh no, Discord server. Just behave yourselves. In the space station thing, we're sharing lots in the research lab. In astronomy, value of a redshift is often denoted by the letter Z, corresponding to the fractional change in wavelength, positive for red shifts, negative for blue shifts, and by the wavelength ratio 1 plus Z, which is greater than 1 for red shifts and less than 1 for blue shifts. Oh, well, that makes perfect sense. There you go. See, I totally understand it now. Math is hard. How did galaxies form after the Big Bang? It was just gas and stars and stuff. We already covered that in stars, didn't we? But if you want to give us a brief kind of, how did galaxies form after? Wait. Red Duck says, I don't buy the whole universe is in black hole hypothesis yet. I need more. Red Dog, I'm with you. I'm like, hey, are we Russian dolling ourselves by saying that? Like, when, that's all in a black hole that's in another black hole that has a black hole in it that's in another black hole, all of its black holes all the way through. But then wouldn't that make the idea of traveling through black holes more interesting if it did become a thing and we just find that that's how you jump from multiverses and universes to another? If black holes were a way to travel through, and we did travel through, and we found that we were just traveling or jumping from one, or if that was the quickest way to jump to another, that if it was a portal and it was just another way to jump to another galaxy that we can see, and it would be about time travel, because if they are galaxies that we're seeing that are long dead, oh my god, that could be a really cool sci-fi theory. Mood Point says, Red Dog, matter can't travel through black holes. Who knows, Red Dog, if we are actually in a black hole, though, and a black hole is in the center of our Milky Way. Matter came out of the black hole. Why can't matter go through a black hole? We're made from black holes. Black holes are made from stardust, right? Same stuff there make good stars. And we're made from stardust. That matters. Right? Or no?
Are you waxing poetic or are you asking me that?
I'm waxing poetic and asking.
Because we talk about with the whole, like the black hole thing, you don't really travel through it. We don't know how you can do that yet. Or if you even survive going through it.
Well, let's throw Red Dog in there and find out. I'm just kidding, Red Dog. We're going to throw Bruce in. I'm just kidding, Bruce. Bruce said, I want to believe that I don't live in a black hole. Thank you. What do you have against living in a black hole, Bruce? What has a black hole ever done to you? Has life been? What's wrong with living in a black hole? We have a black hole at the center of our galaxy. Do you have something against Sagittarius A asterisk? Do you not like Sagittarius A asterisk? Seems kind of scary, sad, said Bruce. Why? Why is it sad to think of living in a black hole? The black hole will kill me, says Bruce.
To like, being shortcuts.
Wouldn't that be great if there's shortcuts to other, to those faraway universes?
But whether it goes to another part of our universe or whether it goes to a different universe entirely is the interesting part.
The black hole has no empathy, says Bruce. Oh my god. Bruce,
it has entropy, though.
Yes, entropy. What's entropy again? Can you explain that to the class? No?
Entropy is the scientific study of how everything kind of degrades over time.
Look at me just ruining press jokes here. Hello, UK racing queen. Are you a hot ringer?
I could ruin my own jokes, thanks.
I want to ruin them too. Red Dog says, matter is susceptible to gravity. Gravitational distortions like black holes would obliterate any matter as we know it. How do you know?
As we know it. No, as we know it. That's true. That's the caveat.
Ooh, using fancy words like caveat.
We could learn more things that get around that. There might be matter that has no mass. Like light. Photons are matter that has no light, or no mass, rather. So light can't escape from a black hole, but what does it do once it's in there?
We don't know. Because what if it's just like people are suggesting, which is that it's just like where we're at right now, and that
enters a new universe?
Yeah.
Maybe.
Like it's just another universe.
Goes back in time? Maybe.
Ooh.
Goes to a different part of our universe where the physical laws are the same?
Would that be funny if it's in our same universe? Just saying. Wait, not funny, but like, oh, we're right here. Okay. Okay. We aren't light, though, says Red Dog. Yes, we are. We're light. We're made of light and stardust. Hey, Red Dog, we're energy. Anyway, Red Dog says matter will always have mass. Matter will always have limitations.
That sounds like 19th century thinking.
Yeah, Red Dog, you're sounding a bit 19th century there, Mr. Red Dog.
Because we've already theorized negative matter as a method of keeping.
Yeah, that's right. Open. That's right, Red Dog. Look at me. I have no idea. Yeah, Red Dog, what do you say about that?
So we've theorized, like, mathematically different types of matter that could allow weird things to happen. And
like what?
Like negative matter and Casimir forces and stuff like that.
See, take that, Red Dog. What do you think of that?
Casimir was a scientist who... I don't remember if this was direct observation, but it was basically if you place conductive metal plates really close together, weird stuff kind of happens, but that's down to like quantum effects and things like that that we still don't understand. So it's kind of like we're seeing weird things happen that we can't explain, but math is saying funky shit.
Life. Hey, we're only 17,304 light years away now. It's not bad. That's better than before.
What?
Just saying.
What?
I was on Elite Dangerous.
Oh, like where you and I are.
Yeah.
How many jumps do you have until the next?
It's 75. It's 75. You guys just don't want to admit, says Red Dog, that our best chance of any of this is AI. Humans can't do it, but AI probably could go through a black hole. I know. I agree.
An AI made of what, Red Dog? Normal matter? Like we've been talking about that a black hole would destroy?
Bruce is like, whoa, calm down, Red Dog.
We could send a signal through the black hole, and it would still get destroyed, probably, right?
Because it's matter, right, Red Dog?
It would
Huh?
be more like what could survive a black hole, and then we would have to send that in.
Yeah, Red Dog. I'm just kidding. Why are we fighting Red Dog? Red Dog's been great. Bruce comes in.
Yeah.
No matter, just energy. So you're saying the AI would just be energy, Red Dog? But okay.
What about how, like in Star Trek, the whole we can go faster than the speed of light because we put the ship in a warp bubble that kind of it moves faster than light. So the ship is fine, but we're warping space to allow us to go faster. What happens if we put a ship in a bubble of negative energy or some kind of weird exotic matter that kind of allows us to travel into a black hole?
Yeah. What about that, Red Dog? What about that, Red Dog?
Well, I'm just taking existing ideas and making an analogy to make other things possible.
I'm just kidding. Red Dog's no matter, just energy. That's correct. Old virgin, I was gonna say, it's just because of Bruce is being funny. Humans are better because I'm a human, therefore we are better than AI, says Bruce.
Wrong.
Good to see you, old virgin. Bruce is just joking. Good to see you, old virgin. We've been talking about galaxies. We also covered a little bit about the black hole idea, about are we in a black hole, because that's trending lately. And Red Dog came in with really great news about the first image of an exoplanet. All that's in our Discord right now, in the my Discord, but in Brad's section of the space stuff and things. Yeah, good to see you. Do you have any thoughts about galaxies, old virgin? While I get near the. Okay, could galaxy collisions create new stars and planets?
Absolutely.
Do you think
in the same way that supernova create new stars eventually?
Would it do it even bigger or faster? Because like a whole galaxy. Wait.
Probably not faster because it would take longer for it to happen.
Okay. Well, Virgin says yes.
But it's like a star nears the end of its life and goes nova or supernova and sheds all of its material into space. That eventually creates a planetary nebula that will coalesce into more stars, or maybe the explosion itself causes stellar formation because the material that's exploding outwards runs into other stuff that's already in space.
I wonder if that would create new types of life or anything. Red Dog says, can we talk about the sheer amount of galaxies and just appreciate how large that number is, says Red Dog. Can we think of anything else that has that big of a number?
Big numbers and I cannot lie.
There you go.
There's a lot of galaxies out there. It's fucking crazy.
200 billion, says Red Dog. He's got a number.
Like Carl Sagan, billions and billions.
It's a lot. That does sound like a lot of galaxies. And do all of them have black holes in the center of them?
The ones that we can see, probably. Most of them do. If not all of them. But there might be way more that we can't see that don't.
Why didn't we discuss
like
that on the black hole episode, that black holes are at the center of galaxies?
We probably did, but it was about black holes and this is about galaxies, and they kind of have that in common. So we're talking about it in both.
Yeah. Bruce says, how do we know it's 200 billion? I agree. Oh, yeah. Red Dog says, wait, I read it wrong. It's 200 billion to 2 trillion estimated galaxies. Holy crap, says Red Dog. Yeah. Both numbers are equally way more than we can conceive of. Except for trillionaires, I guess, that have money. They can conceive of.
That's the observable universe. That there might be more, that the universe has expanded too far for us to conceivably see. So we won't be able to see it. That's part of the tragedy of an expanding universe.
If it's expanding.
I mean, it is. It is.
How do you know?
Direct observation.
You're watching it expand? right now. You're watching the universe expand. I'm just saying. I'm
No.
just saying. Well, then. Okay. That's a huge leap, says Bruce.
Whatever.
Oh, no, whatever. He doesn't bother me. You know,
I don't know what you're talking about anyway.
Old Virgin says we think there are galaxies without black holes, but it's not been confirmed yet. Yeah, Old Virgin, I saw a mention of that there might be a galaxy without a black hole. Bruce says, yeah, wouldn't the real answer just be infinite space since it expands forever? But it's the pop rock. I'm a little confused, says Bruce. It's okay. We all are. I had this note here. I was like, tell me more about redshift, but now I know about it. What are metallicities? What are metallicities? Yeah, yeah, what are those?
Metallicity is a measurement of how much metal is in a substance.
Okay, so what does that got to do with
galaxies and star formation?
Yeah.
Do you remember from the star episode when I know you said it this episode too, where stars will fuse elements from hydrogen into helium and lithium and carbon and all this other stuff up to iron, but after iron, a star can't fuse that on its own. It has to rely on supernovae to make elements heavier than iron. So literally every other element on the periodic table that's heavier than iron, including calcium, which is in our bones, came from exploding stars.
Okay, so
almost all of the elements are metal.
Oh.
Hold on a second.
Holding fuel star. Okay. We don't know what's beyond our universe, says Old Virgin, but don't we wish we did? And Red Dog says there are about 2 trillion synapses in the brain. Love that coincidence. Yeah, there's a lot of coincidences in science and in our bodies and in space and in Earth and in trees and all that stuff. And people attribute it to God, but I get it now. I mean, I don't want to take away anybody's belief, but I get it now why there would be if, let's say, we're made of stardust, like we discussed in stars, made of the same elements. Our bodies are made of the same stuff that are made of space. There are patterns in math and in all this stuff, and in nature. Why wouldn't we have similar? Why wouldn't that continue inside us? Whether it's synapses in our brains or the structure, the structures of trees, like the lung systems of humans.
Maybe our galaxy, maybe our universe exists in a black hole, or maybe the filament superstructure of galactic superclusters are like the neurons in some gargantuan creature's brain.
Right? Didn't we talk about that last time? We might be in a human. I mean, in a robot. Like, it is kind of interesting. After iron, you need to add energy to fuse atoms, said Old Virgin.
Yeah.
And Red Dog.
That's what I was talking about with the supernova thing.
Yeah.
So in astronomy, metallicity is the abundance of elements present in an object that are heavier than hydrogen and helium. So not even oxygen is considered not a metal in astronomy. Most of the normal currently detectable matter in the universe is either hydrogen or helium, and astronomers use the word metals as a convenient shorthand for all the elements except hydrogen and helium. You liars.
What? Wait, what are they lying about? What's the line? Wait, tell me.
This word use is distinct from the conventional chemical or physical definition of a metal as an electrically conducting element. Stars and nebulae with relatively high abundances of heavier elements are called metal-rich when discussing metallicity, even though many of these elements are called nonmetals in chemistry.
Huh. Why?
It literally just said it's shorthand to talk about things that are not hydrogen and helium, because hydrogen and helium vastly outnumber all the other elements.
Okay.
So say there is, because we can detect through spectroscopy the metals in observable objects, so we can look at a star and go, okay, that has more carbon than this other star in it. or this part of the universe has more heavier elements, so there must have been a lot of supernova there in the past. So we can look at galaxies and measure their metallicity that way. It's like a rough average because we're not measuring every single star. We're measuring the overall light and things from all of the stars combined, shining in our direction.
No, they're not really shining. Some of us, you can't wish on falling stars. Don't remind me about the tragedy of last episode. I mean, not the last episode, but the star episode, where I had to learn that we're not wishing on stars, we're not falling stars. I'm not over that yet, guys. I'm okay. Sorry, I know that was random. I'm sorry. I'm just remembering that we're not wishing on stars. Look, you have to check out the star episode to know why I'm suddenly in my feels about that. That's some fucked up shit we got told. I'm just saying. Sorry. Okay. Okay, so I gotta catch up. I'm sorry to interrupt you. Red Dog said a completely irrelevant fact, unrelated to the episode of galaxies. He said, "Hey, fun fact: there are an estimated 20 quadrillion ants on the planet. Kind of cool. I think that's connected to his be right back AFK. Gotta go do husband stuff. My guess is he's gotta go get some ant traps or kill some ants or something. Because why would he mention the other thing?" Bruce says, "F the trees. Where's my algae love?" Wow. Bruce wants that algae love. Algae. Is it algae love? Algae. It's that stuff in the water, like Lake Erie that overtook the water. Remember the algae blooms of Lake Erie? Anybody remember in Canada? Totally horrific. No? Okay. So, like, it was this thing. It made the water really gross. Just saying. It took over the water. Just saying. That's a bad thing. It can be a bad thing. Too much algae is bad for you. No, he's gone. It's over, says Bruce. No. Oh, you're at 600, says Bruce. Oh, am I? Thank you. Thank you for letting me know. Yeah, I hit it last night, and then it went under, and then it went over, and then it went up, and yeah, it's exciting. Thank you so much for subscribing. If you're new here, thanks for subscribing. I appreciate you. And if you're old here, thank you for subscribing. I appreciate you. Old Virgin has a science thing. In astrophysics, everything is a metal because it's easier to think of it that way. Big Bruce says goes down to $5.99. Probably. Honestly, that's why I haven't posted about yet, because I did. I hit 600 and then immediately somebody went down to $5.99, and then yeah. So it is what it is. So I'm letting it go up a bit before I announce it. Why is it easier to think of everything as metal? What if it's not metal? Can't make wood metal. Are they talking about space stuff? Like Brad? Brad?
Yes.
Is that?
I'm here.
Hi. What is that comment about? Oh.
Because hydrogen and helium...
They're not metal, though, so why are we calling them metal?
They're not, and they didn't say that.
Oh, okay.
So because hydrogen and helium are, like, vastly the more abundant elements in the universe, astronomers got lazy and just like, okay, everything other than them are called metals now.
Oh.
Because if they're observing things, and for the most part, it's going to be like, okay, that's mostly hydrogen and helium, just kind of averagey universe stuff. But if things have lots of heavier elements than that, it means that there's been more energetic activity going on for longer. More stars, more supernova, just stuff like that going on. So it's like, okay, that's a little more interesting. Let's kind of check out what's going on over there. Maybe there's life, maybe there's more planets. So it's almost like it's not really a definition, it's more of a categorization to make things easier to like define from their perspective of investigation.
Oh. Gotcha. So it's kind of like that other thing from earlier and other stuff. Like they basically.
Yeah, it's not the chemical definition of a metal. It's like it's just a byword for
Also, this was still based on that question I asked about
Metallicity.
metallicities. Metallicities.
Yeah.
Old Virgin said everything can be considered hydrogen if you think about it. What do you think of that, Brad?
What?
What do you think of that?
I mean, if you want to take everything apart,
Yeah, take it all apart then.
you could disassemble everything at the atomic level and make nothing but hydrogen.
There you go. So, take it all apart. Sounds great. Everything
It's
could be.
like,
Are we hydrogen?
yeah, but most of the other stuff
Guts and stuff.
fused from hydrogen.
Does hydrogen help keep us alive?
Yes, because a lot of
Both.
like proteins and sugars and stuff are hydrocarbons,
Oh. Oh.
which means they're molecules made of hydrogen and carbon.
How do you know?
And usually, like, being a nerd and reading stuff for like 30 years.
Yeah, what if you read it again? Could you imagine how much smarter you'd be still? I don't mean that as an insult. I just meant, like, like if we both read. Like, I'm just saying in general. I used
What
to read a
happens
lot
if everybody
more.
read? Whoa.
Well, that's what I mean. Like, I used to read a lot more than I do now, and now I'm stupid. But I used to be smart and a nerd and read, and now I don't read as much. And can you imagine? Deloitte came in with, you know what else is made of hydrocarbons? Space pants.
You can't make space pants without hydrocarbons.
Good to see you, Pi. It's good to see you. You're so late. Like, we're nearly done, but gosh, that's fantastic. And it made Brad happy. Space pants. Yeah.
Space pants.
Look at my space pants.
Link.
Space pants. Ah, jeez. Ah.
I didn't paste that link in there yet. Oops.
Oh, well, thank you for...
Hey, why did it? Why did it do this thing?
What thing?
It did this where it's like, here's a preview of what the link is about. It's like,
I don't know.
just
Sometimes it doesn't.
some blue words that you can click on.
Mm-hmm.
Anyway, that's the animation of the Milky Way and Andromeda smashing into each other.
Oh, I want to see that. Why can't I see a preview of it? You're right. It didn't give it. Well, then try again. No. I know. It's too late. No.
It doesn't sign you up for Bitcoin or anything.
No context. I need context.
Is it context? It's a website that ends with nasa.gov. It's probably a NASA link. There you go.
I was really hoping it would give it to me, and it didn't. Oh.
Repost.
Yeah, I'm gonna delete it.
Reposting.
I was just hoping it would do it for me, but it didn't do it for me either. I was hoping I was special. I'm on 100% kryptonite, says Bruce. Here we go again. Yeah, space pants. Well, Virgin says, if you smash two hydrogen atoms together, are we talking about sex now? Together, you get deuteronium.
Talking about fusion.
Add another, you get tritium. And add another, you get helium, and so on. Old Virgin Beale, no smart over here.
Buddy, it's talking about nuclear fusion. Deuterium is actually what heavy water is that we use in nuclear reactors.
There you go. But what's that have to do with galaxies, Old Virgin? That's what I want to know. Or space pants.
Maybe space pants are made of deuterium? Because they're space? We're thinking tritium fusion will be part of the next, hopefully, century of energy production, too.
Do you think we'll get there, or do you think we'll just keep going backward?
I feel like we're going to keep going backwards for a bit.
Yeah, same. Oh, well. Maybe the next civilization will do better than us. Okay, so trying to get to 69 jumps. You guys can ask questions too if you got anything about galaxies you want to contribute before we're done here. Is there a maximum size for galaxies? Well, I'm going to read that in a moment, Elfridge. Is there a maximum size for galaxies?
I think so.
What would determine the size of a galaxy? What would make it go, oh,
I'll give
that
you
can't
one
be any
guess,
big?
and it starts with G.
Gravity? Really?
Yep.
Wait,
Well, 'cause
gravity
would
can
have
only pull so much? Are you telling me there's a limit to what gravity can do?
Well, yeah.
There's a limit to what gravity can hold. Even old Virgin said gravity. Why? How do they know? How do you know how much gravity can do?
That's how gravity works.
Yeah, but how do we know? What's the math? What's the number? What's the maximum number of gravity that gravity can gravity? I want to know. I need to know. I need to know.
I feel like that was a smart question asked in a not too smart way.
Yeah, well, welcome to knowing series.
So, sorry, what do you want to know? How big a galaxy can be?
No, yeah. What's the maximum size? What's the maximum size of a galaxy? But how can you even determine how much gravity what maximum gravity is? How do we know? How do we know what maximum gravity is?
So scale down a little bit and think of a solar system where there's a sun in the center, maybe there's a couple stars in the center, whatever, and there's planets orbiting it and comets and asteroids and all this other stuff. But even the largest, heaviest star would have a limit to, at a certain distance, anything that's over there is not going to be drawn to the star. It'll either be drawn to something else or it won't be drawn to anything. It'll just keep trucking on its own direction. There's a limit to the gravitational pull of that object.
It's just not attracted to that gravity.
So it makes sense to reason that even if you scale up, there's going to be a limit to which the gravitational bounds of a galaxy just stops and things at the edge don't stay there anymore. And over billions and billions of years, they would have dissipated or floated away or been attracted to something else. And you would kind of see that clear definitive edge.
Maybe it's just disinterest and nothing to do with what the gravity can hold. It's just like...
Yeah.
The star would rather go on and live its own life, not be like stuck to that gravity, the old gravity. You know what I mean? Like, why are we determining that? Okay, well,
it's not a determination; it's an observation.
Okay, well, Old Virgin says there is a new study just out that concludes that Milky Way and Andromeda only have a 50% chance of colliding. Old Virgin, you should have been here 2 hours ago because I said that. I actually shared that. That is, you're absolutely right. It's a news story, and I actually shared it, but I didn't say it in quite the correct way you did. Thank you, Old Virgin. Yeah, I shared that. I did that. See, I did that. I wish you'd been here for that. You would have been so proud of me. I shared that. Okay, Deloink or Pi has a very important question. How does Brad feel? He doesn't feel. No, I'm kidding. I'm just kidding. How does Brad feel about China's gravity chamber? And can we use it to reach a power level over 9,000?
I'm not sure about what their gravity chamber is. Are they trying to make some...
I guess you gotta do some typey.
Hypergravity thing? I mean, obviously it'll go over power level 9,000. It just sounds too cruel to not do that. But a gravity chamber.
Yeah.
I wonder if it sounds almost like the opposite of how we do zero gravity or microgravity experiments at the space station or in orbit to see how things would act in low gravity environments. So maybe is it like a centrifuge, I guess? Oh man, I gotta Google something.
Yeah, please Google. Yeah, get you on Google. Bruce says Deloink is a genius asking that question. Yes, Deloink is pretty clever. And he's really good at math, too, or something. He used to be a hell diver, but then I guess he gave up on hell diving, so...
China turns on hypergravity machine to compress time and space. What?
What source? Tell me when and what, and put it in the news. Tell me, share in the news. Wait, share.
Ooh, the South China Morning Post. I'm going to go to a less biased news story.
What? Wait. What do you mean?
Chinese news reports China's awesome. Yeah, I'm going to try to find like a more neutral news outlet for that.
There's a while you're looking for that, there is like I've seen YouTubers promote it and I found it interesting, but I don't know how to get it. There's like this news site that you can have that will like not a news site, but this thing that will filter will show you not only the articles but which leaning they are, and it'll show you what is being covered by which side, like what leaning, what bias, and then also what stories aren't being covered by either one, so you could read it from the perspectives of the different bias and know the sources, and it covers like all vast news sources, and it can cover all the topics, so you can research things and get from credible news sources, but also see it from the various bias and or be able to
Could
rule
it turn
out.
like a filter on and just be like, any bias, just fuck off, don't tell me anything because you're
No, it
biased
is.
and you're not news?
Well, it is. It kind of works that way, so it will cite all that stuff. I don't know what it's called because I haven't paid attention to the ad enough to remember, and they're not a sponsor yet. So if I get there and they want to sponsor us, I'd be down for that, and I'd be down for using a trial of that because I'm very curious about using that for a news source because I'd like to. It's better. It's better than I explained it. I don't know if anybody I know uses it,
I
but
feel like not an insignificant number of people would use that to just be like, oh, well,
it's for
I
people.
like this side of the fence, so
No,
all the
no,
other biases, they
no,
just
no, no,
fuck
no.
that.
It's for people
No,
who
because
like
people will
to
be
be.
biased.
No, but I mean, it's generally used by people who do want to critically think and they want to be able to, um, let's say they're doing research or commentary videos or research videos. It's more for that kind of. It is for the critical thinker and also to be able to
I mean,
figure
rule
some
number
shit out.
one, don't go to the news. Go to, like,
Well, it's more than just
scientific
news
papers.
sites. But anyway, yeah, well, now everybody's writing papers, especially if governments are outlawing words like woman and stuff. So, anyway, but did you find out more about this China's gravity chamber thing? You were looking it up.
Yeah, I was.
So,
China's taken a monumental leap in scientific research by activating the world's most advanced hypergravity machine.
I don't see it in the news. Where is it in the news? It's not in space news.
Then go Google it and put it in there.
I can't. You're right there.
Fully
You're,
operational, it will capable of producing forces thousands of times stronger than Earth's gravity. China says this will completely revolutionize research in science in extreme conditions.
oh,
Talking about what gravity is, I understand that. However, hypergravity conditions will far exceed this, creating unprecedented conditions for research. How does it do this?
can you share the link in the space news?
Oh, the Army has one that goes 1200. Maybe when I'm done reading it. The facility is comprised of 3 primary hypergravity centrifuges, allowing researchers to replicate conditions rarely encountered in nature. These machines rapidly spin containers, forcing heavier materials to the edges or bottom, and mimicking extreme gravity. Okay, so it's like the centrifuge, or the spinny thing that you see astronauts get in. Such capabilities make it a powerful tool for multidisciplinary applications in engineering, geology, and material sciences.
So it's
Potential clean energy source found beneath ocean floors and neat. Okay.
potentially clean energy source for real? Wait, they're researching it or what?
I mean, fusion's a potentially clean energy source, and where the fuck are we getting that?
Yeah, we've
Get
been
your
waiting
shit
on
together.
that since the. Yeah, we've been waiting on that.
It's a perpetual 50-year away technology.
Oh, thank you. That's put into research lab. Okay, gotcha. I was thinking that'd be in space news, but I get it. I get it. It's but okay.
If we're talking about it in the podcast, it goes in research lab, isn't it?
There you go.
That's,
I don't
that's
know. Yeah. Okay. So, Overgen said because Einstein gave us relativity and special relativity, this allows us to actually calculate how much gravity affects things around it. When we were talking about that other thing. And Duloing says, fun fact, if Chinese players are griefing or trolling, just type Tiananmen Square in the chat and they'll be disconnected. I've done it many times in Helldivers.
hilarious.
Wow. I don't think I'm actually getting griefed or trolled by the Chinese players, but I have been griefed or trolled recently. So What do I do about that, Deloink? You'd have to be in my
That was
Discord to
funny.
know about that. Does that
It's
really
okay to
work?
look. I get it.
Yeah, I know, because they're not allowed to know about it. I know. I get it too. I'm
So
not dumb.
that's the joke.
I get it. It's a funny joke.
So it's not a
It's
reference to
funny that
anything other than that.
they used to come in and kill everyone before
Whatever.
extract. Oh, wow. Oh, well, look at you, Deloink. Causing controversy in my chat tonight. I value my Chinese viewers, so I'm sure are totally allowed to watch my space podcast.
Tiananmen Square.
Where you go? Cheese. Anyway, Bruce says that's fucking evil, Deloink, LMAO. And then Old Virgin
Running
trying
over
very
civilians
hard.
with tanks is evil too, but hey.
Yeah, that is kind of, that's not cool. But neither is America, so there we go. Okay, Old Virgin says centrifuge equals gravity machine. Seems like China made a big one. They did, huh? So they made a gravity machine, a big gravity machine. And that,
Yeah, that like paragraph I just read and the link to, yeah, that.
okay. So what's the implication of this that excites Duloink? Or Pi, as I know him. Pi Mei, as I... Like, what,
Are you asking Deloitte or asking the class?
I'm asking Deloink. Will China's gravity machine open the eye of terror? Is what Deloink asked. Oh
We can
my.
only hope.
Oh my.
Just the
Oh,
false emperor.
oh, I am at 69 jumps. Aw. They okay. So
I think the exciting part is
oh
the
07 go at sea.
aforementioned potential like energy source. Even if that's not going to happen, it's still an advanced research facility, and the only reason we build those is because we want to figure more stuff out.
Praise to the Omniscience. I don't know. I don't play Warhammer, so I can't. Yeah. Uh, I hit 69 jumps. It seems like a good number for me. I know that, you know, so we're getting close to wrapping up. How did the first galaxy form? I don't know. That's a stupid question. But I do have some trivia questions for you.
That's not a stupid question.
Oh, well, then tell me more.
How did the first galaxy form? Mm-hmm. I wonder if it was like really gargantuan. It was all the matter in the current universe.
Wait, if everything was all one thing and then it broke apart? Is that what you're trying to say?
Maybe. We don't know how the early universe looked. It was like crazy energetic, and then the gas dissipated and cooled down. Because that's how the gas law works.
I didn't know there were laws about gas. Okay. What's nowhere?
But yeah, the first galaxy. I don't know.
Deloink being totally off topic, but not really, because we did talk. What is more scary, a supernova or a black hole? Totally keeping on topic of galaxies.
I guess it depends on where you are. Like if you're.
Yeah, if you're near.
If you could be kind of far away from a supernova and it will still totally fuck you up. You have to be kind of close to a black hole for it to fuck you up.
Mm-hmm.
But a black hole has more like unknown kind of spookiness about it. Like we don't know what happens inside. Whoa, don't go near it. Then supernova's just like, okay, it's like an explosion. Get the fuck away from it. They're both dangerous. I don't know.
We don't know how
supernova can only get so large. So I'll go with black hole for the ultimate answer to that question.
Wrong. No, I'm just kidding. Old Virgin says we don't know how galaxies form, and Red Dog says black hole. Red Dog agrees with you, Brad. And Old Virgin says depends where you are. Ooh, trivia. You all can answer this before. Brad can't see your answers because he's not in the chat because he doesn't support my channel. I'm just kidding because you're supporting it by being part of it. Okay.
I'm chaotic neutral. I support no channels.
Oh, well, that's great. Thank you. No, he's supporting by being so helpful. So here's my question.
I'm in the podcast.
Yeah, you are in the podcast. It's very supportive. Um, okay. You guys can answer this as well, and I'll tell you guys what you can put like the letter, and I'll tell you guys if you're right, and we'll see if Brad's right. What holds galaxies together despite their stars moving too fast for a visible mass alone? Let me get you probably already answer. Just hold on, okay? A. Radiation pressure. B. Dark matter. C. Cosmic rays. Or D. Magnetic fields.
I feel like that could honestly be a question in Who Wants to Be a Millionaire.
Yeah. Do you need to phone a friend?
No,
Oh, okay.
that friend is me.
So what's the answer? What holds together?
I'm gonna go with dark matter.
Oh.
Final answer.
Final answer? How about you guys?
You need some ominous music.
We got dark matter by old origin. Red Dog was saying it was magnetic fields, but I don't know. And DeLoyne says you forgot E, the Care Bear stare. The answer is dark matter. The answer is dark matter. I'll give you guys longer next time because you guys seem a little slow. Let's go. Okay. I'm just kidding. Oh,
Care Bear stares pushes stuff apart.
Old Virgin says magnetic fields could also have something to do with it. You're right. But the question was, what holds galaxies together despite their stars moving too fast for visible mass alone? And the answer was dark matter. Okay, let's go on. Which type of galaxy often forms from mergers of spirals? A. Spiral. B. Elliptical. C. Irregular. Or D. Ring. Which type of galaxy often forms from mergers of spirals? A is spiral, B is elliptical, C is irregular, D is ring. Lock in your answers, folks. A, B, C, or D. Brad? Do you need me to read the question one more time?
No, I'm just thinking about the answer, because part of it is like, well, how do we know? Because we haven't really been around long enough to observe, like, oh yeah, we totally watched two spiral galaxies smash into each other, and they turned into this. So, okay, smarty pants, what do you think it'd be?
Well, I have the answers.
Well, yeah, so it's easy to comment when you have the answers. So I'm kind of thinking elliptical, because if you smash these things together, it just forms like a big messy shit. But I kind of want to go with ring as my answer, just to see what happens. Go with ring galaxy.
Okay, so I'm going to first give everybody else's answers. They were saying C, so irregular was Red Dog. DeLoyne said the answer is yes. Red Dog said, I don't know if it's C, though. I don't know if it's irregular. Old Virgin says irregular. Buddy Bud said, this is fun. And Brad, the answer was...
I'm liking the not serious answers.
The answer was first guess, best guess. So you got the answer wrong. The answer was elliptical.
Okay.
You were right. Your first gut instinct is elliptical. Which type of galaxy often forms from mergers of spirals? It was elliptical. So yeah, you should. I was like, oh, you got it. Oh, you did it yourself. You know. Okay, so we got another one right here. We only got a couple more. What is a starburst galaxy? Remember, chat. You guys can answer this too. And Brad's going to answer. What is a starburst galaxy? A galaxy exploding. B, a galaxy rapidly forming stars. C, a dying galaxy. Or D, a galaxy with only old stars. What is a starburst galaxy? A.
It's B.
It's B. He's going with B. Brad is going with B. You guys? What are you guys doing? Old Virgin says rapidly forming stars, which would be B. Red Dog says B, but I don't know. He's always saying, but I don't know. Anybody else?
It's
Last
always good to
chance.
have it out in your back pocket.
Yeah. The answer is B, rapidly forming stars. So if you guessed B, rapidly forming stars, like Brad did and Old Virgin and Red Dog did, you guys got it right.
Applause
Okay.
all around. Woo!
Woo. You all got it. I don't know who has the most points. Bruce, are you keeping track of points? Like Bruce, what anybody
Oh,
keeping
this is
the
like Cruise
points?
Line. It's all made up and the points don't matter.
Oh, okay.
Except for the science part that is not made up. It is fucking serious.
Why do we see distant galaxies as they were millions or billions of years ago? A. Their light is too dim. B. Light travels at finite speed. C. They're behind dust clouds. D. Their light curves around black holes. Question again was, why do we see distant galaxies as they were millions or billions of years ago, which we kind of talked about earlier. And so again, A is the light is too dim. B, light travels at finite speed. C, they're behind dust clouds. Or D, their light curves around black holes. So we've got answers in the chat. But DeLoyne says, I have the most points because I believe I have the most points because, Old Virgin says, we don't need points.
Deloitte knows orcs.
So what's your answer, Bruce? Not Bruce. Fuck it, Brad. It happened again. It hadn't happened so long.
Light travels at a finite speed.
Is that your final answer?
Yes.
That is the correct answer. So, yeah.
Bonus points. What is that finite speed?
Yeah, light travels at finite speed. So Old Virgin got it right. Red Dog got it right. I'm going with light curves around Uranus. DeLoitte, I didn't fall for it this time. It's Uranus. I learned that in the solar system episode. Uranus, right? Did I say it right?
Yeah.
Thank you. You were hoping I'd say it wrong, weren't you, DeLoitte? Haha, you caught me. You didn't catch me or whatever. You know what I mean. You didn't catch me. Whatever. There.
Words
and stuff. Old Virgin said, if you're a photon, though, you don't experience time. Wow, Old Virgin. Red Dog says, the physics questions I'll crush. I'm actually really bad with the astronomy stuff. Old Virgin is like 30. I don't know. I can't even do that. Uranus. Uranus? Wait, Uranus? It's Uranus to you?
Is that like his fraternity?
He's saying Ura. Are you saying Ura, Duloink? Is that what you're saying? Because, no. It's Uranus, I believe. Didn't I learn it to be Uranus? I believe I learned it to be Uranus. Anyway.
It's Uranus.
Yeah, it's Uranus. Okay, last question. Okay? You have one last...
For all the points.
All the points. All the points. And you lose all the points if you get it wrong. What do gravitational lenses do? A. Block light from distant galaxies. B. Magnify and bend light from distant galaxies. C. Emit gravitational waves. Or D. Pull galaxies toward them. The question again was, what do gravitational lenses do? A. Block light from distant galaxies. B. Magnify and bend light from distant galaxies. C. Emit gravitational waves. Or D. Pull galaxies toward them. For all the points.
I have my answer.
Is it your final answer?
Yeah.
Okay.
It's E. It lets you see galaxies. Like glasses or lenses, so you can see galaxies.
He tried to be funny again. It's
B.
Really?
Gravitational lensing is actually pretty cool.
B. You're saying it's B?
It
What do gravitational lenses do? Unfortunately, the answer is B. Oh, wait. Magnify and bend light. You got it right. Okay. So, Old Virgin. Okay. First of all, DeLorean said refract light. What the hell are you talking about? Like, old Virgin said bend light. Red Dog says B. Yay. Yep. And Deloitte said all my answers are the same as Red Dog and Old Virgin. Yeah, there you go. So you got that. Brad did not pass that. No, he passed it. He got one wrong. But he wouldn't have had it wrong if he'd gone with his first gut instinct. Brad's like, I was hoping you'd forget already.
No, it happens.
It happens. Like immediately he's
go with your gut.
Go with your gut. That's what we learned today. Yeah, so
I mean all that galaxy stuff too, but most importantly go with your gut.
Yeah. So there you
Don't
go.
doubt yourself.
Don't doubt yourself, yeah. The whole episode is like you are made from galaxies. Don't doubt yourself.
Well, it's like a 90s TV show for kids where it's like, yeah, they'd have some adventures, but at the end, they're like, here's the important lesson.
Right? Don't doubt yourself. Yeah, you're probably...
Don't litter.
Yeah, don't litter. Oh, I miss when it was like, don't litter. Remember that? So I'm stopping at 69...
Yeah, remember when the social mentality was not to be a piece of shit?
Yeah, remember it's like, don't
wow,
litter.
What a crazy time.
Don't litter, and, you know... So I am ending this at 69 jumps.
I have 100.
Oh, well,
exactly 100.
There you go.
Where are you jumping to again? Are you still in the game?
Yeah, I've got to go to PROE Haipu FHU E32. I think you said it's like, oh wait, what is it called? The carrier is called something like, is it a carrier?
Rocksteady.
Yeah, I'm going to Rocksteady, guys. I can't wait to get to Rocksteady. I'm going to Rocksteady. It's a fleet carrier, though? I'm excited.
Yes.
I haven't been on a fleet carrier
you're outside
forever.
of, I don't think there are any other stations aside from the Colonial Highway or the center of the galaxy. Like, you're far enough out now where you've left civilization behind.
Yeah, and I'm trying to make it back to the galactic center. Rocksteady and Bebop, exactly. So is the next... Okay, we have a question from the chat. Deloitte says, it's the next episode Space Weapons and Space War. Here's the thing. We did decide that we would go back and forth between science-y space to like, which we still got to explore our mind a little in this episode, which I still enjoyed that we did that for a bit. And then we're going to like the sci-fi again. Yeah. So I don't know if space weapons, did we do space weapons already or not yet? We did weapons in space or something. We're doing something like that. We could do something like that. Let me look at our thing.
We talked about war in space already. Mm-hmm. But that was like 5 weeks ago.
Yeah, we did. So you guys really want to talk about freaking laser beams, don't you? That's what this is all about. You guys are all like, can we get to the laser beams already? The freaking laser beams. You know, they're going to make another... Oh, guys, do you know they're going to make another Spaceballs movie?
Yeah, I heard about that. Rick Moranis coming out of retirement, which is awesome.
I can't wait. I'm so happy that he's going to be in it. And Mel Brooks is going to be doing this too. I mean, how exciting. We live in exciting times. Everything is going to shit. I'm like, but Mel Brooks and Rick Moranis, I mean, come on. Life ain't so bad.
It's all worth it.
I'm sad Pullman died, though, said DeLoitte. Oh, wait, we're in it.
Yeah.
Yeah.
Yeah, me too.
Yeah.
I remember hearing about that. It's like, Mr. President, no.
Yeah.
He was the president in Independence Day. The first one. The only one.
Yeah.
The only
first
Independence Day that was
pretending
ever written and filmed.
Nothing ever. Aw.
There's no bar because John Candy's passed away too. So.
Oh my God, that's right. There's no John Candy and there's no Joan Rivers, which is fine. But I mean, there's no Joan Rivers or John Candy either. So like basically almost all the cast is dead but Rick Moranis. Wow. Well, I'm glad Rick Moranis
Mel Brooks is in it too, so Mel Brooks will be in it.
He's also the director, right? He's the guy who did the first one.
Yeah.
And a very
But he was
great
President Screw.
Yeah, so he's gonna it's gonna be interesting. Anyway, it'll still be great. Let's not think about the rest of the cast all being dead.
Bigger and ballsier.
Yeah, oh my God.
Excited.
It's gonna be great. I mean, either way, even though I'm sure they'll I had somehow Mel is still alive. Yeah, he's like, I don't know. We did get a question from Red Dog that said, when are you guys going to make a top 10 list in an episode?
A top 10 of what?
list. Yeah,
like anything?
Like a top.
How about your top 10 planets of the solar system? Oh,
What? Oh, no.
you can't even get to 10.
There's no Pluto.
I have thought about the idea of sort of
really old for a chick?
not really dedicating an episode, but like having an episode focusing on like specific sci-fi franchises, because there is a lot.
So it should be everyone's answer.
So it's like, hey, here's one about just talk about Stargate and ideas and things put forth in Stargate.
Wait, did you? Wait! That got me so excited. You mean we could? We could talk about specific universes. DeLorean said Mass Effect, and I am excited about Stargate.
Yes.
Oh
Mass
my
Effect,
God.
Stargate,
and then connect these things to science and oh my God. And your homework would be to have to watch the movies and or TV shows of all these things and or play those video games. Okay. Oh my God, I want a Stargate one. Holy shit. Okay.
Please.
I'm so excited.
All the homework is voluntary.
Star Trek. Oh my God, can you imagine?
When we talk about Warhammer, your homework is to collect an army, and then you can talk about it.
No, and Warhammer, I'm just going to like be shutting my mouth. I'll be like, what? Welcome to the Warhammer episode. I'll be like me. I'm just
You don't have to be invited to the Warhammer episode then.
Well, oh my God, I'm here though.
If you're not going to have any fun.
I'm not saying I won't have fun. I'll have to just put on my learning hat and we'll be totally being this.
It's kind of like Helldivers, where a lot of it is just satire based on his history.
I know.
It's just an
aliens. Oh my God, aliens. Yeah, aliens as well. Red Dog, don't get too excited. I can't. I gotta calm down. I was already excited about Stargate.
Aliens.
No,
or even stuff like Event Horizon.
Aliens is. Oh my God.
That's not really a franchise, but it's a movie.
But certain movies, I don't know.
Stuff like that.
We could do that. I hope you put
or
that
maybe
in your notes.
What? Oh, that's what I mean. It was already a note. Talk about sci-fi franchises was a possible idea.
I gotta catch up. So, only Mel could get Rick to act again, Red Dog said. Actually, no, I think Rick Moranis was ready. He'd been ready. He'd already done some sort of test in the waters. You know, he had to deal with raising his kids
after
the death of his wife. And
he only left acting because his wife passed away, and then he was like, kids. Hey, Hollywood, it's been a ride, but I'm going to go raise my kids. And the whole world was like, holy fuck, what a dude.
Yeah, but he's back, and I'm very happy.
Kids are grown up, so it's like, I'm going back to fucking Hollywood.
Yeah, I'm going to go make some money, and I'm going to do great now, and plus, he did love what he did, so I'm glad he's coming back, and I'm glad
we did too.
We didn't need to see any more Honey, I Shrunk the Kids movies unless they do something better. So it was probably for the best. Julian says, somehow Mel is okay. Pluto should be everyone's answer. What else did I miss? Stargate, yeah. Oh no, we'll be totally into Slanesh, Duloink. You don't know me anymore. I don't know what you guys are talking about. What does that mean? No, don't have me if I don't know what you're talking about.
You'll have to wait till the Warhammer episode to find out.
And Pi, you better get back on Helldivers. Let me show you what the Illuminator about. Get back on and let me show you what the Illuminator about. Come on now. Aliens. Read what I wrote to Brad. Oh no, he'll get it. Yeah. Okay. So what is it about, Slanesh?
You'll have to wait till the Warhammer episode.
Moranis is a man for walking right. He is so Duloink. He did the right thing. How about I buy Space Marines for your day for my birthday, Duloink? I like money, but I don't know that I will play Space Marines for my birthday. Oh gosh, you know what though? A free game. It is pretty expensive.
Quite a lot of novels.
I mean, the game is like, what is it? Like, that's pretty generous of you, DeLong. I mean, I'm not gonna say no. Because that's a game I don't want to pay for. It's like a lot of money. Oh yeah, if there's any, that's really sweet of you though, DeLong. My birthday's coming up. My birthday is like July 25th. I don't know if you know that. You'd be into the books. I don't have time to read the books, so you'd have a better chance of making me play the video game than reading the books. Let's be real. I got Proust here beside me and Brave New World, and they're not getting their loving, you know what I mean? So I'm doubtful that I'm going to read some more Hammer books right now, you know? I could be read to, though. Horde mode just came out. Yeah, on Space Marines. I heard about that. I am in the Helldiver community, so I did hear about the Space Marines getting Horde mode, which, yep, keeps raising eyebrows. Yeah. There's Horde mode in Aliens for Ultimate Elite. Chat, let's buy her a Warhammer Plus subscription. What the hell is that? Deloitte, that's a, you know what? Deloitte, you get, mm, mm, the, look, you know what? In the description of the video, you'll see some links, Deloitte. If you're talking smack, you're talking smack. But there, you know, there's some
I
links in there.
appreciate the Warhammer references.
Yeah. I don't understand any of them, but I get some of them because of the Helldiver crossovers. I appreciate you guys. So just me and Brad, you're going to get so into this universe. So I'm still, I don't know. I don't know. Do I want to go down that rabbit hole? I know there's a lot of crossovers. Is that what you're doing? Is that why you're neglecting your Helldiver duties, Deloitte? You're playing Warhammer all the time now? Is that where you are? I'm just saying. Okay, so why did we end on that note? So galaxies, do we have any highlights? We had a great quiz. We talked about galaxies. We talked about...
What's your favorite galaxy?
The Milky Way, because we live here and it's our home.
That's my least favorite because we live here.
Oh. DeLong says, yes, future child of Slanish, you will be a fan. I have no idea. Buddy Bud says, thanks, so no, and Brad, great destruction. Wow, why did I just read it that way, Buddy Bud? I'm so sorry.
Okay.
Great destruction. It was...
Discussion?
Yeah.
Discussion.
He said discussion. I'm sorry, Buddy Bud. Buddy Bud, thanks for showing up at the start. You know, always holding it down for people in the community. Appreciate you. Appreciate everybody that stopped by, including Bruce and Old Virgin, even though you're late. If you were late and you actually are curious about what we talked about in this video, please go back and listen. Not just for the views, but because we did cover stuff. It was really fun. It got really fun when you guys all showed up at the end there. Thanks for being late. And Brad was great as always. Thank you, Brad. Even though you won't.
Thanks for coming out, everybody. That was a fun episode.
But it was, yeah, not as good as... I'm still hung up on the stars one. Red Dog says top 10 scariest things in the universe. Red Dog's trying to make us go viral with like a top 10 video, I bet. Is that what you're trying to do, Red Dog? Julian says, always fun, Brad, and oh no, thank you. We appreciate you guys. Andromeda, because I can actually see its beauty. Oh, Old Virgin. That sounds lovely. Yeah, Andromeda. And plus the Andromeda just sounds prettier than the Milky Way. Like, literally, we named a chocolate bar. I mean, I don't know. Why do we name it? Oh, question. Why is it called the Milky Way? I know we're
like
supposed
the galaxy
to...
or the chocolate bar?
No, the galaxy. Who named it the Milky Way? Why is it called the Milky Way?
I think...
It's our galaxy. Why didn't I ask that at the beginning? Why?
Because ancient astronomers looked up and saw the band of light in the sky, which is the disk of the Milky Way from our perspective. And it looked like milk, I guess. Hold on a second.
Yeah, please Google that. Well,
I think that's it. Like, it's a weird...
Red Dog says, damn straight, I'm a mod with no one to ban. We need you to get mega popular. Oh, Red Dog, I could have used your help recently in the past few days. I don't know, Red Dog, you need to check out that new channel in the Discord called That Is Very Human. That Is Very Human is a statement Bruce made in it. Believe me, I could use some moderation still in life and in the channel. I think especially now, the closer we get, the more we get. I'm definitely needing the mods. Nobody's required to be here if you have a wrench. I'm just saying it's very helpful because, yeah, I could use some help. Duloink says because of space nips. Wow, Duloink. So you're thinking of the Milky Way, they looked up and they thought of tits. I don't think that's what happened. They probably drank milk even back then, like what, milk from animals? Why? I don't know why, but Did they
Well,
just
see, the
think
milk
there's
from
a...
animals or
Oh,
milk from not
It
animals.
would be
Anyway,
from
in
milk from
Western
woman.
culture,
Oh,
the
wait a
name
minute.
Milky Way.
Oh,
Am I gonna read this or what?
you're gonna read
Read this.
it.
In Western culture, the name Milky Way is derived from its appearance in as a dim, unresolved, milky, glowing band arching across the night sky. The term is a translation from the classical Latin Via Lactea, a term derived from the Hellenistic Greek
Wow.
Galaxies, short for Galaxies, Kyklos, meaning milky circle. There, I almost tripped on my words there. So yeah, it looked like milk to people, or it's like a milky, hazy kind of band of light, and that's what they called it.
There you go. And they were probably thinking titty milk because probably that was more common. Yeah. Yeah. Probably. Milky Way. Because it looks milky and cross the sky like a road, said Old Virgin, sounding way more poetic than I just did. Thank you, Old Virgin. Because it looks milky and cross the sky like a road. The
The
Milky
English
Way.
term can be traced back to a story by Geoffrey Chaucer in 1380. See yonder, lo, the galaxy, which men clepeth the Milky Way, for it is white and some parfait. Attributed to the House of Fame, from 700 years ago almost.
Wow.
Next.
Wait, when was it actually called the Milky Way? 700 years ago?
It was in a story from 1380.
1380. So it's only been called the Milky Way since 1380? I wonder what it was called before then.
In English, it was called things in not English by the Greeks.
So, but not the Greeks. But what about indigenous people? I wonder what they called it. I wonder what other people called it. The Milky Way.
It's only a Google away. Yeah.
It's only a Google away. It's only a Google away. Donkey milk was choice back in the day, says DeLoink. I guess you'd know if you were there. Whoa, I'm kidding, DeLoink. You were great. I insult people on the way out.
I'm drinking no ass milk.
Wait, gross. What?
Donkeys are called asses. It's ass milk.
Gross. I mean, this is turning. This milk is turning. DeLoink says lots of space things use Hawaiian names and technology and terminology. Oh, like what, DeLoink? I need examples right now before I go. I don't believe you. Sorry. No, I believe you. I'm just kidding. So there you go. Thank you so much for being. I believe you, DeLoink. I just don't know if you have time enough to type any examples. Like, can I have an example?
I think.
Mua, says Old Virgin. UMUA. MUA. I guess that would be, wouldn't it? Oh.
What is this? Hurry up, Wikipedia. Let's go.
I don't know what that's showing.
Oh, this is from the Easter
There you
Island.
go. DeLoink agrees. Yes, Old Virgin did give an example. So there you go. So you guys are so smart. Thank you. And thank you for other people who aren't as smart for making me feel not so bad as a co-host here to Brad. So thank you. We all help each other. That was a great episode. I want to dip. I got stuff to do before the playlist tonight. So I appreciate you guys for being here. Thank you for having shown up. And if you do listen to it on the replay, I hope you enjoyed it. And the pinned comment is the Discord link. If you're scared of it, I understand, but that's where the research stuff goes in. And you guys are wonderful. Thank you so much for watching and supporting the channel.
Thanks, everybody. That was fun.
DeLoink had to say it. Thanks, Unknown Brad. This episode is brought to you by Dixon Cider. Thanks. Wouldn't be an episode if DeLoink didn't say that. It's still funny. I made it awkward at the end. That's great. Brad, can you just say what you say? Because that's so much better. No? He usually says, I have to go. My planet needs me. It sounds better.
Well, I was going to say it.
Oh, I ruined it. Oh, nice.
Well, it's too late. No, she said it.
I said this.
I was looking at the pictures for a second to make sure I got everything for tonight.
Oh.
I logged in late. Anyway, I have to go now. My planet needs me.
See the. Okay. Bye, guys.
Bye,
Thanks again.
everybody.